I feel like for the first question, well, just a minute, I'm for it first.
Oh, no, you said something about the first question?
Yeah, well,
The essays, short essays?
yeah, so the short essays, I feel like for myself, I feel like I answered the question,
Oh, okay,
but I just wanted, not talking about me individually.
Yeah.
But, I wanna, just, sorry, 1 second, please, because I want to see exactly what it is. So yeah, I feel like I just didn't understand like how like ambiguous or general you wanted us to be, and for me, like I felt like as long as I understood the general concept, and I felt like I did, and I could probably just say it right now and still like know it to the T. And then even then provide all the details that I didn't know I needed. So I felt like that was a little bit like it threw me for a loop just to not have enough, I guess, or I don't know what was too much or not enough, or yeah.
okay, so, those questions were listed, so you had time to practice or whatever, get as much detail or knowledge about it. But you're right, everybody's gonna have a different idea of what is a good answer for the question. So I try to write little on those questions. I try to write little tiny things because to show you, maybe you didn't mention, like somebody mentioned sewer, and I heard that in the class, that was a big deal. I mentioned sewer and it was really water. Well, it is a big deal. I mean, it's a totally different problem if it was a sewer problem versus if it was a water problem. And the pump handle and all of those types of things. That's really what he did, and that's what we talked about in class. So it kind of depends on every individual, and those kind of questions we'll have to answer. But the idea is that what I want everyone to know is you knew the essay questions that were going to be asked of you. And so they were listed there. I didn't ask all of them. I only asked 2 of them. So everybody had forewarning that they should really kind of focus on those areas. Even though it's more areas than was asked, it still at least gave you knowledge of that. But I mean, I will, each individual person who has answered it and felt they didn't get their proper credit, then we can talk about it individually. And usually the way I do that is you will write up a response for yours to say you should have gotten more credit because you said this, 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 and this, and this is what basically should be said. So we can talk about that, how to do a regrade, if that's a question that you want to ask. But what about anything else on there? Yes?
I would just say the only thing that really kind of was a little bit hard on the exam was when it came to the matching letter portion with like the actual diagrams. I think it was just a little bit hard to see because they're kind of small. That was for sure the thing that kind of was a little bit difficult for me.
Like osmosis, like I could not tell, like I looked
Oh yeah, like
to
the
it,
osmosis.
and I was like, I thought that was a water molecule, but it was the one to the right that was the water molecule, but
Yeah,
it's so hard to see sometimes.
Uh-huh.
So I was
not
like,
even the photocopy.
Yeah, so no, I mean, it is obviously the photo thing, but I can make them larger, so that's really constructive because I can. I mean, I thought I made that one pretty large because I wanted, is that the one with the water molecules or?
it's the one with
Yeah,
4, but like they're so small,
Oh,
I could not
yeah.
tell if that was water or if that
Yeah.
was, and that, like these, like it's just hard to see some
Right.
of them.
Yeah, I think all of those were on the list of everyone should look at these, so I was hoping you would be able to recognize them. But I can see that, because several people asked me, is this what is on this figure? So I knew it was hard. Even though it was in color, it's still difficult to read them.
I think the only other one, in my opinion, was like specificity of grading for like some of the diagrams. Because I wasn't 100% sure. Like some of mine, like I may have missed like if I missed one specific of the actual letters for like one of the chemicals in like a disaccharide or like the peptides or something like that. Was that like what would make the grade like a complete 0 for like one of the answers or something like that?
So the answers were, there was a little number before each question to say this was a 2 point or 1 point or whatever it is, or at the top it said these are all 1 point, whatever. There was some indication what each question would be. So generally for those, if there was 2 answers, you had to get 2 answers to get all of it right. If you got one of the answers, you got half a point, and then 1 point if you got both answers. On ones that was only 1 answer, if you put the wrong answer, you would get 0. or if it was, one answer was only correct and another answer plus the correct one was put, then you gave a good answer and a bad answer, and it came out to be 0. So you didn't get half a credit, because sometimes, you could put 3 and 4 answers down, and try to get some kind of credit for a problem. So it indicated that maybe you didn't know the answer, if you wrote a wrong answer and a correct answer. So that's how I graded that.
And
Yes.
then-
Oh, go ahead.
Okay. So for like some of the questions, I think I went into it thinking like I went into it thinking like, for example, question 2 was to describe the type of bonding. In my mind, I was like, oh, if I just say hydrogen bonding, but I'm like, oh, she wants to explain it. So I'm like, do I need to explain it? And then I kind of sat there and went back and forth with myself over, do I need to explain it or not? And how much should I explain if I do?
Mm-hmm.
And so like sometimes like the wording of the question threw me off a little bit.
So I think that one had to describe.
Like describe, so like.
Yes, so
describe
that
would be,
means
like,
just, yeah, okay.
hydrogen bonding, like how much do you want me to explain the type, like what the characteristics of like water molecules are, hydrogen bond, like just a little overthinking on those ones.
Mm-hmm. So if you overthought it, did you not write enough, or did you write too much and got points off, or
I
what?
wrote
Or did you
too
get
much,
credit?
I got too much, I got a 1.5 out of 2, but too much into detail and then got marked off at one of the lines. So like, it was like if I wrote less, it would have gotten full. So I think, is it
So
like,
maybe you went too far into saying something that.
yeah, so is it like if we write, let's say we write something, we get the right answer, but if we go too much in detail on something irrelevant to the answer is wrong, you'll still mark off a point for like the actual problem, for example?
If
Let's say
something is wrong in an answer, and it indicates you don't understand that particular problem, whether it's a little ancillary to it or not, there would be points deducted, yes. Oh, yes.
Okay, so for like the homeostasis, or sorry, the buffer question.
Okay.
You said short answer, so I kind of just was vague, I guess, is what you said.
Yeah, I can't remember what the question,
It just
exactly,
says-
not your answer, but what was the
It
question?
just says what is the function of a buffer short answer.
Oh, okay, yes.
So I just did like one sentence, and so like that, my answer was in part correct, but then I got marked off for not having other parts that you were probably looking for.
Mhm.
So I guess just maybe something helpful I thought would be if in the directions you maybe included like what key terms you're looking for, that way we know like what you're putting points for. Not like
Yeah,
giving
yeah.
the answer, but just in
Yeah.
a way being like, make sure you include in your answer this X, Y, and Z.
No, then I'm giving you the answer.
I know, but I'm just trying to think
Yeah.
of like, I don't know how to phrase it, but I'm just saying like there's, with other professors in other science classes, like that's just something that they, like given, I don't know how to explain it, but in problems where it's free response, that's kind of what they include, like make sure you are discussing something about hydrogen, like hydroxide and whatever, I don't know.
Yeah.
I don't know how,
That, to me, that would be like giving it away, but,
Yeah.
I'll try maybe to eliminate those kind of questions then and make it a little bit more essay.
Yeah,
Yeah,
Okay.
so that way you'll,
Well, I think these open-ended questions, there's I think a loss of interpretation, or you might interpret it a different way than what we do, and so then we get marked on. So that's,
well, that's what we're gonna do individually. You can come individually and say, why do you think your answer is right? I mean, I hear what you're saying is, any question is gonna be open to interpretation. What is a buffer? I think that was, one of the questions in the textbook that I said, these are the questions that you could be asked. I went from the textbook.
like, it says, what's the function of a buffer?
So what,
It's a short
well, I
answer.
don't want to ask you that question.
And
Uh-huh.
I put the short answer, but then you mark off a point, you said.
Well, we'll have to talk about what your answer is, and so, I can figure out, did you really understand what a buffer is by the words that you put down? I mean, on paper, whatever the grade it is, that was my grade at the time, but if you think that there's something else in your words that I didn't understand, then that's where we come together when you talk about your exam.
Can I clarify something? So like, for example, like your short answer question number 2 about the importance of observation, documentation, and scientific inquiry. So when like I read that question, my mind goes
That was
to,
one of the little essay questions?
yeah,
Yes,
okay.
uh-huh.
So like when I read that question, my mind goes to, okay, you're gonna look for us to explain observation, documentation, and scientific inquiry, right? So then when I'm like explaining it, I wanna make sure I hit those points. And so I'm not super worried about the exact detail of like the exact population versus like, for example, I'm just gonna say I put the word people instead of saying the word like children, one of the things, right? But I explained in detail about how he documented, how he observed, and how he, but then like.
Like a particular person or something?
Yeah. So like I use the word people and like for population because I was focusing on how he observed, how he documented, and how like that.
You're saying he, so is there a person that you?
Yeah.
were writing
It
about?
was
Okay.
about Samuel.
Winnell and Semmelweis.
Yeah.
Oh, that one, okay.
Yeah,
Uh-huh.
sorry. So like I was explaining that question, and in my mind, I think where like the thoughts of confusion goes is like how specific do I need to be? Because if I miss like one aspect of it, it's 0.5 marked off for every like aspect, which takes away from like the question. But I think like overall when it comes to observation, documentation, and scientific inquiry, the 3 factors you're asking about, like I feel like I aced those parts. So it's like maybe I don't know like how we could like clarify it because on a test when you have so many questions to do, you're trying to get the main part of the question answered. So I think that's like what threw me off for like many of the points that were marked off in my case.
I think, I agree, because I think it was in that question specifically, like when you see observation, documentation, and scientific inquiry, those are like the 3
Where
like
I'm going.
keywords that you want to like make sure you have in your answer, because that's how I felt, or specifically what's being asked. Obviously, I like in my answer personally, I tried to include what the background of each of their observation was.
Well, that's what the questions, I mean, it's specific people, why are they important? What did they do? What did they observe? How did they report it? That kind of thing.
Yeah.
But
So
then,
that's why I gave you specific people and not just
Yeah.
general.
but then she was saying in terms of like the actual answer itself, when I specifically missed points, it was not because of me not explaining the observation, documentation, or inquiry. It was more because of I didn't explain exactly what like their specific incident of it happening was. Like if I missed like a specific detail or like a key word, like in terms of like handle or pump handle or something like that.
And then it's like 0.5, it would be like 0.5 off for each of those.
It was
which
just a
in
little
this grand scheme adds up to a lot.
Confusing.
So
with
yes,
the word.
yeah, and I agree, but something like the pump handle, you know, if you're talking about snow, that was major. That's how he stopped the epidemic.
Yeah, well,
So,
Yeah, well, maybe then like if you give us, like, if you were to give us a multiple choice and put 3 different things on there and 3 different options down there and then change the wording, then we would be able to select the correct answer and that would tell you like that you tested our knowledge correctly. I feel like that would be more fair, you know? Because then I'd be like, okay, there it is right there, and like it's like, you know it. You know, versus like, oh, I didn't write a broke pump because maybe I grew up learning that it was a pump. Maybe I grew up, or you know, who knows, or whatever.
well, I mean, oh, yeah.
But I'm saying, like, you never know, like, some people call, like, things differently, like, I don't
No,
know.
I mean, it was on the slides and we went over
Well,
in
yeah,
class
I
and we
mean-
described how you.
I mean, yeah, but, yeah, there's different, like, things that happen here.
I think I'm just more, like for future things, I think I'm more stressed out when it comes to like the open-ended responses. I think now I'm going to be so like over picky with, like I just want to know, I want, if there's a way to clarify some, and like if you're asking like clarify some parts of the question, or maybe make it about one person, so that way we can just fully go in the biggest detail rant about that person. Maybe it would have been like, because now I just feel like I don't know how to answer the questions in the most detail that I can do to not get, but because 0.5 is not a lot in the grand scheme, but when you add it up, 0.5, because it's 0.5 usually, it like docks off a lot on your grade. I don't know how we can fix that, but like, that's just the main thing that I noticed in the whole exam.
Or maybe just wording of questions.
Maybe.
yeah, maybe. I did also have.
Allowing us to give clear answers probably interprets. Right,
Allowing you to give
so,
clear answers.
in what she was saying with that multiple choice questions, kind of allow us to, I guess, give you the correct answer.
Just do multiple choice then.
Or is
Yeah.
there more of the like the short form answer, like the one worded ones, where you like want the specific term or something like that to test more of the knowledge of what specifically happened?
I just think if you allow us to choose from a bank of answers, it gives us
a better ability to describe what you interpret as the correct answer compared to what we interpret the correct answer to be. I mean, you can give us like,
Yeah, cause you could
you can
say,
give us 10 choices to choose from, but in there, you'll have the one that describes what you believe the correct answer is.
Yeah.
You don't have to give us 3 answers or 3 different options, because that's a small bank, and gives us a higher probability of just like saying whatever and guessing what the right one is. But if you give us like a larger bank of things to choose from, we can find something that best describes what you're trying to get an answer out of us.
or if population does matter a lot, and children is important to you, and the water and the plot line is important, then in the question, it could be phrased, could be like, in people, and the other question could be in children, and then like, it could, then we have to test, do we actually know what population, and that tests our, if we use observation. I don't know, because I actually don't mind short answer, it's just like, now I don't know how much I have to write about in order for the answer to be correct. The short answer, this is a good question. It was a good question, I just don't know like, how specific to be on the question.
Maybe just in the question phrasing, like add, like, not necessarily to give us the answer, like I know that's obviously, like, you could include, like, make sure to include who this was done on, or something like that, just to make sure that we actually do include that. That'd probably be helpful. Oh, and then I did have one, sorry, I've been trying to get it in. I did have one question on one of the specific, how this one was graded. It was one of the specific one answer, like short form, questions.
Exothermic one?
The reaction to release energy was it was the exothermic reaction one. I mean, I put exothermic, but then you have the,
I think it wasn't, the answer wasn't exothermic, it was exogonic.
Yeah.
So that's what biology, that's what we had on the slides.
No, on the
So for
slides,
metabolism,
you also have exothermic as releases energy on the slides.
but that's when it's releasing energy. These were metabolism problems, that's what that was.
So,
focused
this
on.
one said reactions that release energy. It didn't say,
So, I mean, that would be one then, when we meet about your exam, that you can point out that.
Can we just give us that point now, because like that was essentially
Well,
one who
some
missed
people
it.
got that right.
Yeah, they
So
can
it's
get
not
the
really
point.
fair to them.
No, I know, but they can get the point, but it's not
So
fair
I'll
to
just give them
us.
extra points?
Sure, but it's not fair to us that that's on the slide and we did dock the point when we see, and I read the chapter 2 and it has an answer. And you weren't specific on what you.
So I think, for that,
So,
since
yeah,
everybody's pretty much in agreement, I'll just add 1 point to all exams. Is that worth 1 point?
That's fair for me.
Okay, so that's easy, then we don't have to worry
Yeah.
about that. I'll just add 1 point to all of them. So just someone has to email me. Well, no, I'll write something up right up there. Yeah, because I mean, I think there was maybe 50 people got it right, but I would rather give extra credit to the people who got it right, than to have to take every person come up and discuss that particular question.
Yeah.
I would say just maybe in the future ones, because since there are, I mean, obviously I know it is the more proper one you were looking for is exergonic, but maybe put in metabolism or something like that, just to make sure that we can differentiate. Because that was the only thing, like, since there's like 2 specific terms for something, that's where I didn't know which one to put.
Yes.
Why is the term variolation necessary for question, sorry, we keep switching. We're like this. Why is variolation a term necessary for question 1? Is it the 14th century Chinese practice?
It was because that's what he based his trying to take the scab of one and give it to the little boy. That was something that was practiced before, and it just was not, it was practiced a little bit in the United States, but not much. So he had prior knowledge of that. And so that's why he knew, I mean, he didn't know that this could be an antidote, but he said it would be a safe thing. He did not want to do the smallpox, which is variolation, is doing the actual disease. He didn't want to do that. That's why he did the cowpox. But then when that worked, he goes, okay, and he said, I'll do this, and he turned it vaccination. But it used to be called variolation. That was practiced for a long time. It just was so dangerous because if you gave somebody something that was pretty deadly, you could in fact kill them.
But in the slides, there's no mention of that term or genocide. So how would we know that?
Well, I think it's in the textbook, yeah, the whole section of it.
But was there like the tie to say like?
To gender?
Yeah, was there the tie to say like he knew about it, he thought about it and wanted?
Well, I think that was the introduction to the whole, vaccination. I mean, I'll look it up again, but yeah.
So if we wrote down like it laid the foundation to vaccinations, because that's true, correct?
Yes,
That was,
I mean, that laid the foundation for him
Yeah.
to take the steps that he did.
yes, so if you say that, but we didn't mention variolations, then that's marked off, correct?
I'm not sure, I think quite a few people had 14th century medicine, and I think I counted that as at least them knowing there was prior knowledge. I can't remember now exactly, but I remember seeing quite a few people that had 14th century
And then if we wrote,
medication.
is it in?
Oh, so yeah, let's not do yours individually and stuff, but,
No, I'm just trying to read your, in correlate, what does that mean? In court? In correlate?
so let's do it individually. Yeah, I don't want to tear somebody's exam apart in front of everyone, so I just, so let's go, yes.
Yeah.
I guess I'm just like a little confused because I remember like in the first couple of classes, you said that the textbook wasn't completely necessary as long as we had the slides. So we're getting points taken off for stuff that was specifically just in the textbook, so.
Well, there was a lot, I mean, all the figures and stuff came from the textbook, so you have to have
But
something.
those were in the slides, so
Pardon?
those were in the slides that you provided to us, so it's like, so
I don't know if they were,
A
a lot of the figures that were in the like slides that we saw in class were on the exam.
oh, yes, but I
But,
think there might have been a few, I can't remember.
But you said like variolation was in the textbook, but I don't think it was in the slides, so then we're getting points taken off for the text, no, you know what I mean, so we do have to technically have the textbook.
You need to have some text, I mean, you can't just rely on words that were said in a lecture and then feel that you fulfilled the course. I mean, the course has a textbook. I don't care if you get that textbook, but you should get some textbook. Yeah. Yeah, I mean, even the coordinator doesn't require, because I think there's Wiley Plus, or I'm not sure what the program goes with it, doesn't require his students to get that, because it's just an extra cost to the students. So any older textbook usually would do. Yes?
And then, one more question just on also when we were drawing the figures for, disaccharide and
Yeah.
the peptide bonding. The last portion was what molecule was released in both, so like it was obviously a dehydration, so water was being released.
Exactly.
I put H2O in mine specifically, but when, so you had underline show this in your drawing for future, would you want us to actually draw like a 2 hydrogen to an oxygen bond? Is that what, because I did lose points on that one, I was just, is that specifically how you want us to show it?
So the only way you can show that water was released is when you have the first molecules, and in the text or in the figures that was on the slides, they had the OH and the H, the ones that were released. So you would circle those just like it did in those slides, and then that's what you would show was coming off.
Okay.
So somehow to show it was released from the molecule that you made. It's no longer, the OH and the H is no longer in the molecule that you made.
Okay. I was just confused because I didn't know if we specifically needed to actually draw like the diagram of them. Because I think I did see one of the models it just said water being released in the dehydration. I was just a little confused. But for the next one, you'll want us to actually, any type of reaction that has dehydration or hydrolysis or anything, you want us to actually have them like shown in a drawing.
Yeah, if I say, I'll give you these two molecules and you need to make, them together, then you should be able to show which of the ones that you released in order to bind the two together.
Okay.
Yeah, on that one, I don't think very many people got that one right, and I was kind of surprised because it was one of the things I had listed. Yes?
For the section where we would match the capital letters,
Yes?
for 5C, why would G not be considered?
I don't know what 5G is.
If
I think you want me to get an exam or quiz, or exam?
Yeah.
Let me get one so I know what you're talking about. Or if I even brought this. Yeah, I don't see it right here. Let me just look at yours so I'll know what you're talking about. Oh, yeah, okay, so this is the one about the slime layer, okay? No, the only one that has a slime layer is this. That's a capsule.
So this outer portion wouldn't be a slime layer?
No, yeah, it's a capsule, yeah. So this is the only one that's slime layers, that diffuse part that's out on the outside. So you can read a little bit in the textbook about that. Yeah. Let's ask about individual ones and just try to get the whole exam, because otherwise I'll be going around each person and asking the individual ones. Yeah. So the question was about the slime mold, and there's really only one that's a slime mold. The other one is a capsule.
And then for the capital letter one,
Okay.
or which one is a biofilm? Can't both be interpreted as a biofilm because yes, there's a pili on it, but it's also considered a biofilm.
Okay, so that's probably more specific to your quiz or your exam. Yeah, I mean, I don't want to answer individual questions about it. I mean, this is conceptual because you have to be, I mean, we'll have more quizzes and more exams, and you have to be comfortable that you know what's going to be asked. So I thought the study guide, so that's one thing we can talk about. Was the study guide bad or good or didn't give you any information or gave you too much or what's?
Do you make the study guides after you make the test, or do you make the study guides before you make the test?
I make it before. Yeah, so I give myself, these are the ones, because I don't make well, this one I already gave last semester. So I already know what people should get on it, because I've already given this exact one. But I usually, and that way then I narrowed on my study guide from when I did it last semester, I narrowed that study guide to fit this a little bit more carefully. So that I didn't give you too much more to study.
I completed the study guide, maybe I'm wrong, but I don't believe they had any questions on there relating to identifying things such as osmosis or flagella, like you didn't put the specific ones in there. Because I know that, I mean, you put like, I think you had flagella, and I think you had pili and other things like that, but there was only like 3 or 4 examples, and then on the test we had maybe 11 questions about them. So I didn't see a definitive list of what exact things you wanted us to have an idea.
So you went through the figures, because I see it said, you know, pay attention to that figure and this figure and that figure and that figure. That's kind of how I got my figures from the textbook. So.
Is there a way, this is just like a random question to throw out there, is there a way to consult with, I don't know how much more work that adds onto you though, with the other professors in terms of how much they pull out of the textbook versus the slides? Because the slides are kind of generalized, right?
100% is from the textbooks from the coordinator.
Right, so like, the way, no, I mean, you know how like we were saying you make your exams in your own unique way based on what we do in class, right? Which is better that way, because it's better way, but what I'm saying is like, do you know if the other professors are doing it so that we so textbook heavy versus like all the figures being mainly from like your textbook and like some specific questions? Yeah. Do you think there's a way to like cross-reference that?
The only thing I know is the coordinator takes quizzes that you do online. So the quizzes are from the test bank from the book, and they're randomized. So there's 8 questions on each topic. And so you take the quiz, and if you didn't pass, then you take it again. And you can take it like 3 or 4 times, and every question is re-randomized. So, I think a couple of texts that I've had, they say, it's horrible, we hated it, and blah, blah, blah. So I said, well, I don't usually do that. I want to make sure that you've heard it or seen it or something. I don't know if he does, I think he does do study guides, but his study guides are mainly chapter 4, whatever sections or something.
Right.
I don't know. It's usually pretty individual. Teachers usually allow teachers to teach the way they teach. I would not like to just give multiple choice to students. It doesn't feel like, to me, it doesn't feel like it's real knowledge that I get from a student. I don't really know what they understand. I'd much rather give something where I hear and see what they have to say.
Yeah, not
about
like
the
a
topic.
text experience.
And then, chapter 3, you said you made the study guide prior to, but I didn't see a study guide for chapter 3.
I think it's on there.
Or am I the only one that,
It was posted like Sunday before you came.
I still don't see it on mine for some reason. I don't see it on mine. Maybe, maybe we can check.
Yeah, that might be fine.
And so like that just really threw me off because like I felt like I wasn't prepared for 3, like I felt like I was rushed through 3, like just in general, like during the discussion, the lecture discussion. And then after that, like not having the material, like when I needed it, I felt even like more pressured to like cram everything. And then going into pictures was kind of random because I think of that more as like a lab thing, so that was a little bit like, okay, but luckily I did okay there, but.
So are you a part of the Discord that everybody's part of? So did you, I don't know, do you guys help each other like that, saying, I've gone through this, and I mean, did you not know at all that chapter 3 was on there? Because that would really be a big disadvantage.
I knew it was gonna be on there, but I was just like, I just didn't feel prepared, like I didn't feel like.
You wondered why it wasn't on the study guide?
Yeah.
Did you ask anybody why it wasn't on the study guide? Or did you guys get a study guide or something?
I think I did. I was like,
disadvantage, that would be.
yeah, I think I did, but like, I just ended up just like studying on my own in general, because I'm more of like a study on my own type of person. Not really, I mean, I'll look at the study guides, don't get me wrong, but I just was like, it's too last minute to like,
Wow.
and I don't remember seeing it, honestly, I don't even think it's on my canvas.
No.
The
think
study
it's on
guide,
campus, but I don't know.
the study guide was nice. I just, personally, I have a lot going on with work and school and other classes. This is my only class. So if I could just have more notice for the study guide, I know it was posted on Sunday, and most people aren't doing stuff on Sunday, they're relaxing, and I wasn't, luckily, but I completed it. But I work during the week, and I come here like an hour after I get off of work. So I don't have a lot of time outside of class and outside of work to get things done. So if I just had extra time, like maybe if you could just post the study guide a little bit sooner.
I think that's very valid, yes.
Just so I could like fill it out, like, if I could get it done on Saturday, and I could spend all day Sunday working on it. But then if I get it done on Sunday, then Monday I have to go do all the other things.
No, I agree, it should be much earlier. Yes?
I just want to say I agree with him. I mean, some of us are older students here and we work full-time jobs and we have,
I agree.
my day goes from 5 o'clock in the morning. I got home at 11 o'clock last night. No excuses. I know I'm responsible. I'm here. I'm a student. I'm a grown-up. But, I mean, we have to consider, like, life outside of this classroom, too. So
No, definitely, I will.
we appreciate anything you can do for us, and we totally look forward to moving forward.
And then like you said in the past, like how students have done good and everything, and like honestly, that kind of makes me feel personally like it doesn't make me feel very comfortable, because like I work my ass off, like here, outside of school with my child, with like everything that I do, I put 100% into it. And so like when I hear you make those comments, it's like very discouraging.
I'm so sorry, yeah, and I think that's why, and I don't know why the great things were hidden, but that is a comment that had been made.
Yeah.
They don't like, and that's why, like you said, something,
Yeah.
the range was whatever it was to whatever it was low. That's one thing I never want to hear. I don't want anybody talking about, oh, God, we had somebody who had X score. You don't want to do that, and I think that's why maybe they don't post that, so people don't look around and go, I wonder who that was. So if this becomes an issue here and anybody feels bad about it, I'll just take them off. And I can tell you what the high was. And
like
then
all
we'll just
power
leave it
to
at
the
that.
students that are just studying like awesome jobs.
No, I totally agree.
We're like
I
working
understand.
just as hard, it's not like.
Everyone is an individual, and everyone's going to have their own pace. And what you don't really realize is, as we move on, we have these couple major projects, and those major projects are almost 100% for students. I mean, it's towards the end and you get 100 points for something and 100 points for something else, and the grades really come up. But just at the beginning, we don't have very many points, and so any point makes something look bad. I mean, you get 1 point off on something, you, oh my gosh, that just brought my grade down. And it can, even when I was putting in the
Pre-labs.
Pardon me?
The pre-labs.
Well, the pre-labs or the post-labs. The post-labs are 2 points. You put a whole bunch of those in, and all of a sudden the grades are going up, and I'm thinking, oh, 2 points won't make a difference as we start getting 300 and 400 points already
Those
stacked up.
.75, nah, they're adding up. Those .75s.
Yeah, but,
So-
yeah, instructor, I mean, yeah, those points add up, because, I mean, like, I missed points on this class specifically for like, what do you call it? I'm sorry, guys, I'm out of
Be
words.
late or something.
Yeah, just like participation, and it's
Uh-huh.
like, what participation are you looking for in here? I mean, like, I show up to class every day, I'm here on time, or,
Yeah, the only
And it's like-
participation is the lecture class. The lab is a pre-lab and a post-lab. This is the only place that's participation. And I think everybody who's come with a little card has gotten it for the lecture.
well,
Do
Yeah.
you think that pre-labs could considerably be less, not docked off as much? Because like, what if we just like did not understand the lab manual well enough? And then, cause those are like, are those not participation points usually? And like, those
They're not really, the most important thing for lab is for you to be prepared when you walk in.
Right.
That's the most important thing. And so, having students have to read the lab in order to do the pre-lab.
Right.
Because the questions are, you could pick them out pretty much, but.
Like, you wish we could just find them directly on the pre-lab.
Yes, you
That's-
could, and if that's the student's choice, and they're not gonna read the lab, and they're gonna walk in and figure out, what lab are we doing today? There's nothing I can do about it. But at least I can encourage and give points for someone who will go through and read the lab and
Yeah.
fill out the form. So I try, the post-lab, I'm becoming very, very lenient on now. I just, because it can be difficult to fill out correctly, and it's only 2 points. It's not worth a lot of time, not my time and your time, to be really diligent. But you should be learning something from it, because those
Yeah.
post-lab and pre-labs are questions that you are gonna find on lab questions. So that's why also they're important, because where I will take them eventually is from the pre-labs and the post-labs.
That makes sense.
And as we move forward, most of the lab questions will be the stuff that we physically did in lab. And that means, just knowing what gram stain is and what color it is, and, what the order of all the stains are, and, what would happen if you left one stain out, and, all the kind of stuff that you physically do. So you should be thinking about it as you do it.
Yeah, because the lab's kind of changed for us. It's like you either go like, all the classes are going either behind or doing some or not doing something or not giving all the supplies.
Mm-hmm.
Yeah.
Okay, so anyway, my last comment when we kind of started this is, you have to feel comfortable. You have to say, I trust that the quiz or the exam will be something that I can do. The questions will be worded in a way that I will be able to answer them. I will have enough time, which I'm always conscious of. I'm watching to see as you're doing it. But if you're not comfortable with that, you kind of give up before you have the quiz or the exam given to you. You just go on, I didn't do well last time, I'm not going to do well this time. And if you feel that way, then we're kind of lost. So that's why I wanted to have this. I need to build your confidence that I hear what you're saying, that I will try to get things written in a manner that will not feed the answer to you. I'm not one for that, to say, oh, make sure you include this and this and this, but will be more specific, like maybe on the one that we're asking about the epidemiology, I can say what they discovered, how they discovered it, blah, blah, blah. So that doesn't tell you at all, pump handle, it doesn't tell you at all water, it doesn't tell you at all what they did do. It just says, I'm looking for these 5 things. So that would give you, if you knew what they physically did, you would be able to kind of bullet point it into those 5 trailing things. Yes?
Yeah, I just wanted to just make a super quick note, just like you said, like feeling prepared. Like that's kind of just where I felt, I'm not saying I didn't feel prepared for this, I just, when we took like the quiz for the lecture and like the lab, I just felt like, obviously I felt prepared for those, and then when it came to this, I just felt like, obviously, like you were saying, maybe there was just like a disconnect with the questions. If they were a little bit more, not saying multiple choice, obviously, but if they were a little bit more similarly worded to like the quizzes, I feel like it'd be a lot easier to like actually relay what we had.
Right. I'm trying to make the quizzes similar to what the lab quiz was and what the lecture quiz is. I'm trying to make them more direct questions and easier so that you can build up points with that. But the exams will always be, I don't want to say a magnitude more difficult. They will always be small essays. They will be calculations you might have to do, things like that. So it will be, they will be more difficult just by the nature that it's an exam. But the quizzes will be very similar to what you had seen before, and everybody basically did pretty good on there. But again, that's what I'm trying to make sure that you feel comfortable, that you will continue to study, so that you'll get the best grade you can. And then also look forward to some of the things that are coming, and you see big projects. So those are things we can talk about too. You know, how did they go in the past? You know, how long did it take? You know, what kind of grades were given? We also have a presentation. I mean, I think people got perfect scores on the presentation and mostly perfect scores on their major projects that they had to do. It's because you had a lot of time to do it. You could redo things. You had the lab manual, which gave you all the instructions exactly what to do. So I think that was really helpful to give people 60, 70, 80 points all at once.
Are we able to ask any questions about some of those like upcoming assignments as well right now, or?
Yeah, what kind of things are?
I was just wondering for like some of the things like the Blue Book drawings.
Yes.
Is there any way that we could get like maybe not saying like an example of someone's Blue Book in the past, because obviously you could just copy that. But like, is there like a more structured like guideline on what specific things we need, like for each individual drawing, do we need to have the actual conversion like labeled out and done the math next to it, or like what do we need to measure with the microscope, or any specifics like that, just so we don't make sure we don't miss any of those like additional points or anything like that?
So on the Blue Books, there's no sample. I'm not allowed to give you a sample of them, and almost like you said, last semester, I think I had mentioned, we had people that had pristine drawings, exactly like the figure. And then we had a couple of people that just sketched. And so you could see they were looking at the microscope, they were sketching and stuff like that. They did the true thing that we wanted to do. Not take your time and go home and look at slides and just draw exactly what was there. And because most of those people missed the background, which is part of one of the questions, say we'll also do the background, but they didn't. They did exactly the organism. Basically, they probably looked online and they found stuff and they did it. You know, that wasn't so much the issue, but the person who kind of just hand drew everything and they shaded in with pencil and stuff, I mean, they had their measurements right there. Then they said exactly how many marks it was. They said what the calibration from their microscope was. Those are the kind of things that are important. But I do think on that slip that everybody got, it does say these are some of the things that you need. Yeah, and that little thing. Every drawing that you need is in there.
Oh, okay, right, yeah, the calibrations, front cover, specimen names, magnifications. So this is basically the rubric at the very bottom?
Kind of, yes,
Okay.
yes.
Okay, just wanted to know.
Yeah. And it is, it's another thing that it's either almost all, and I can't say it's all or nothing, because I don't think anybody got nothing. But it's a high marked thing. Most people got really good scores on it. I mean, the only points I could be taking off is when I couldn't find something. Something wasn't labeled, and so I said, well, this drawing could be it, or that drawing could be it. So they had drawings, and I counted how many drawings, but there was just not labels. and some of them not, maybe putting the magnification that they used, that kind of thing. But everything else, I mean, they got pretty good scores on it.
I personally am not very much of an artist.
Mhm.
Not very
Me
good
neither.
at drawing things.
Yeah.
I'm right there with you, man.
Yeah, so like, I mean, I'm gonna try my best, obviously, but are you like grading me on like, how
No.
beautiful does it look?
No, like I mentioned,
know.
there were people who did pristine drawings, and I could see that, you know, they looked at something really different than maybe what everybody else looked at. And then this one guy, and I haven't seen him, he's looking through his microscope and he's sketching over here and stuff, and some of it was really kind of sideways, and but then when I looked at the slide, I go, that's exactly what you see when you look at a slide. It's not pristine, it's fuzzy sometimes, it's, I don't know, and really, his book was the best. And because he had every other detail, I could then see how big it was. He even took some of the drawings that were long, and he did a measurement this way, he did a measurement this way, and he did a measurement this way again, to say this is how long the thing was. And other people just said, oh, I just measured the top and I figured the bottom was close to the same. So you could see effort, and that's what I appreciated in that notebook.
Well, you're gonna see some effort and some bad drawings.
Well, I mean, it's not a drawing contest. It is, can you represent in some way what you saw? And almost every drawing, you know, you could show your notebook or your blue book to anybody else, and they would recognize probably what they are. And they're not perfect. So no, I'm not doing it on how perfect that you did. But I am going to do it if you don't have any measurements on it, or you don't tell me what your magnification was. And you have to be careful in magnification, because there's total magnification and there's objective. So you can't say 40x I used, because I say, well, is that 400? Did you use, you know? So I'm not always sure what the thing is, but you have to be very specific.
So like we put like, if we're using like 100x, but it's actually 1000x total magnification,
Yes,
you rather put 100x and then in quotations, 1000x?
yes. Or you can just put 1000x total magnification.
Alright, then I can put like TM.
Yep, that's, I think, what they use.
Is it okay if we like abbreviate objective like OBJ next to like the objective lens?
You probably don't even have, well,
Cause I have both
you don't even have to
online.
say that. If you just say use 40x, I mean, it's not, you don't have to say it's an objective lens.
Okay.
Because that's really what the notebook is all about. So you don't have to write all that kind of stuff out. Okay, so, yeah, so I'm just saying, in the future, when you kind of look at some of these projects coming up, there's a lot of points associated with them. And I know there was time spent on the notebook, but that's, I think it's like 75 points or something. And it's something you did in lab, and it's not like homework you had to do. I mean, some of you probably fancied it up or drew in colors or something at home, but it's not something you have to study for. It's just points that you get as long as you've done the thing that's on the rubric on the bottom. And the same thing on, we have 3 practicums coming up. And so the microscope practicum, I am going to do it exactly the way the coordinator does, because I see now I'm never going to catch everybody looking at the microscope. And what he does is he takes the microscope, he takes a single slide, everybody does the same slide, the same microscope. When you're done, the next person comes in. Start. You know, you get everything in order at the microscope, you know, put the slide in, you put the oil on, you find it, you wash it all off, you clean your microscope, you put it away. Okay, but the next person comes. So,
Are we gonna prioritize that tomorrow?
pardon me?
Are we gonna prioritize on that?
No. Your experiments are always a priority. It doesn't matter to me if it takes me 3 weeks to get everybody up to wherever I'm going to put this microscope, up to that microscope.
Oh,
Yeah. And also you can fail it, meaning that you don't get all the score, and you can say, I want to do it again.
Oh, see, I like that.
Yeah, and so, but it takes
Thank you
Well,
for
I
that.
think it's 30 points for the actual microscope observation, but I think there's 10 points off if you don't pass the first time. You get an opportunity, and it will be 20 points the next time. And I don't know, that's the only thing that on the agenda or
Technically.
Can I redo that exam?
If you're like, looking at the microscope, let's say, oh, you can't find, you're trying to find the organism the first try. You can just, in regular lab, you always can just, okay, let me try again. You can't just try again there, or are you like first
No,
time
there's,
buying.
I think there's a time frame, and I can't
Clock's
remember
ticking,
exactly
you're
what the
out.
time frame is,
Oh, you got
that you
Hey,
need
here it
to
goes.
be able to find, something, especially on a prepared slide, they're not, and that's why I was asking everybody, which one is your favorite? Something that was oil immersion, if you can find one that you really like, that's the one I'll use. Because you say, oh, it's easy to see this particular thing, I think somebody said E.
No,
Was
they
it
say
the-
absolutely.
yeah.
Somebody yelled out right away, oh,
Yeah,
let's do the E.
Yeah, that sounds like a great idea.
I
Actually,
do that.
it's very difficult, Professor. You should use the E.
Tapeworm solar.
I think.
And I think that's one most people, a couple of people mentioned, so
Oh,
that's on my
that's
list now, and I
massive,
think
so.
that's a 100X
I
also.
think you should do the flea.
You know, I did mention that when I was in the back.
That was
I
hard
asked
to
the-
find, dude.
I asked the
That was
Andrew,
horrible,
I said,
dude.
which one would you think to do? And I said, I think I'll probably
Too
do
much
the
light,
flea, 'cause that's
you're
the easiest. He
screwed on
goes,
the flea.
no, don't do that one, it's
No,
too easy.
don't
Oh,
listen to him,
no.
don't listen to him.
I said,
Remember,
well,
they're
what's
not
another
my class
one?
anymore.
And then he was looking through a couple other things. I said, don't worry, I'll ask them. And that way then you guys will all be happy with the one that you're
Kind
gonna
of
You were
fun.
the professor, not
One
that
micro-
man.
Yeah, You're your
That
own
man
person,
over
you're your
there.
own instructor.
But I don't think that the flea, did you have the 100X? No. Do you have the, I don't think
Well,
you
now
did.
No, but I could do it.
No, but it has to be oil immersion. So whatever you look at, it has to be oil immersion.
Oil immersion.
You're the professor, you can do
No,
anything.
the instructions say it must
Take
be oil
control of
immersion,
the
so it will be.
Is it gonna be the same for all of us, whatever?
Yeah, same for all, that way then, no one can say,
They got it easier.
there was something wrong with the microscope, or there was something wrong with the slide, or whatever. So, I mean, and I agree, because he said that's why he does it that way. And I said, well, I just let them do their gram stains or whatever. He goes, but if their gram stain is tough and they can't find it, and
Yeah.
somebody can find theirs easier. So he said, this way, if you give them something to do and everybody has the same, the grades will be.
I
The
feel-
bowl-
I feel
the
like
bowl
the
box.
Prometheus
We should do a bowl box for
pretty, like,
sure.
I think
Yeah.
Bowl box is pretty easy to find. We should do a bowl box.
Oh, yeah, so which the one that has the little eyes in it?
Here.
Oh.
Oh,
Yeah.
Wow.
That was too hard.
Zoid or whatever?
Yeah.
What?
Yeah, that doesn't seem that bad.
Wait, which one?
The trophy.
Anyway, you can think about it, as long as it's 100X, that we use, then I will ask, and I'll just fill the slide out.
Did you say you wanted us to wipe off the oil immersion on the
Yes,
lens
it will
too?
be the whole thing, yeah, you'll do the whole little package deal.
Oh.
His idea is, do you know exactly how to handle the microscope? And I mean, we've done this a lot now,
Is this,
we've cleaned it up a lot, so I don't think there's any problem. In fact, I think last time there was maybe only a couple people that didn't pass.
Sir, that oil on that immersion lens, listen very carefully. You have a big piece of paper that I don't
Yeah,
have.
well, maybe I'll give you big piece of paper when you look at it, I don't know.
Bring our own.
Okay, so let's, so the thing is, my reason for having this today is, it's gotta be a unified lab. Everybody has to work together and feel comfortable that you can ask anybody in the lab for help. If you're stuck and you see that they're done, you can go to them and say, I'm really stuck on this, can you help me? So I think that unity comes with you being happy, being where you are, and also being happy that you can ask me questions. I get really busy, there's a million other things that I have to do, but I also have to realize that you need help when you need it. So I may ask someone to help. If you're done with your thing and somebody's there struggling, and I have to go do something else, I'm gonna ask, can you help this person? And that's how you should be in lab. And I know you have this Discord now, so you are helping each other study, you're helping each other get through the class. And so it's about this time of year where people start dropping. And we don't want that. So if everyone can band together and pull that person through, but it's obviously the person also has to be able to get through.
I'm gonna need a whole rope attached to you.
Well,
The Lord.
but I mean, if you have support groups, but I mean, there are some times when you're just not gonna make it and you just have to say, okay, I give up. But you don't wanna give up until everybody's given it your honest try. And I don't know when that last date is, but, and I think it starts with, more camaraderie and more feeling that that you can say what you feel is not fair. There's only some things I can do, like I probably will not change anything to give you a test bank where here's the answers and you just pick the answers. Even if I have 20 answers and you pick them, I'm just not that kind of person. I want to see that you can yourself come up with the word. And I know that that has to be very specific. And I've done those ones where I do 3 words in a row, we'll fill in the blanks, because I think filling in those blanks are really hard. Because the whole sentence is kind of bizarre sometimes, and those come from the test bank. And I don't like those, but if I give you the words, then it makes it much easier for you. And that's what I think I did on the last couple of things. And the ones that I didn't give you the word, it was really obvious, and I think everybody got those right also. Or most people did. Okay, so are we good now, or?
Yeah, I want to thank you for sharing this.
Yeah, seriously, thank you a lot.
And thank you
Well,
for taking the time.
Yeah,
That's honestly.
It's our lecture.
I think I'm just
I-
like, this is like a therapy session for all of
Well,
us.
you just can't believe how important come in the middle of the night, because it's not middle of the night now, it's only 6 p.m., but you come from work, or you come from studying, or whatever, whether you're a full-time student or you're not, you still have to get going and come to the lab. And unless you're happy and you greet everybody and hi, everybody, what's going on, if you don't feel happy coming here, it's going to be a drag. And 9 o'clock is going to seem like it is forever. And now it's pretty much, oh my gosh, it's 8:45, we got to clean up. So that's how it should be. You should just be shocked that it's over.
It's very fair.
Yeah, I'm just glad you asked for our opinions. I have another professor who I was talking about who won't let us even ask a question like that. Like, what can I do better on the test? That's a no-go for her.
You can't
So,
do better.
Yeah, yeah.
I mean, there's only
Just
some
be
things
better,
I
I
just,
guess.
I want the rigor of the course to be a certain rigor. And I want your grade that you earn to be the grade that you earned. But there's so much coming up that you will earn lots of points that, I mean, if you can make it to the points where we're having the unknowns, you'll make it to the end. So you just got to get there. Yes?
What would you say like a percentage of your students get A's in the class by the end?
I've only taught this class once before, and they ended up to only be 9. And out of those 9, 4 of them got A's. Maybe one more, I think, maybe 5. And there was maybe a couple of B's, and there were 3 C's. And of the 3 C's, there was one really close to a D, but pulled through at the very end. And that person stuck with it, tried and tried and tried, and everybody banded around that person to try to help them through. I mean, sometimes it was getting late at night, and they were all kind of sitting around saying, here's your Bunsen burger, here's this, here's that. They were all really helping to get that person through. And they tried so hard. But I mean, I wouldn't have given them the grade unless they actually got it. But, just the last couple of assignments just pushed them over that edge. So.
Can we have some time on, I don't know if anyone said this already, but can we have some time on Thursday just to kind of like, maybe 30 minutes just to make sure like that we have like everything in the blue book if we have to go back and like get a slide or something?
Yeah.
Or can we show up early to lab and see if we can?
Yeah, we can do early to lab.
Okay.
The only thing is, we have 2 experiments that are in the hood, and you see how wide that hood is? It's like this wide, and everybody has to do their experiments in the hood. So it's not, you can't be like 4D. You have to give people room to get away, and so it's got to be kind of structured. So I've kind of already structured it with, everybody has now tables of groups of 4. So 2 people are going to do one of those experiments, 2 people are going to do another one. And then there's also an experiment we have to do where we use OD ratings. So one person can kind of go away from their person that's already in the hood getting things ready, and they can go and start the OD. And then the other group that comes in, gets in the hood and gets done, then they can go finish the OD. So it's got to be something like that, or we won't finish. I think that one, we finished almost an hour later than the class. And our class got over at 10 o'clock then. We went from 7 to 10. And the cleaning guy was standing there, he's fuming because he's only supposed to work till 9. And here he is at 11 o'clock at night. And we kept going, trying to finish. So I'm trying to rearrange it this time, now that I know the bottleneck. I didn't realize the bottleneck before. And so everybody waited to the end to do that experiment, and they're all waiting in line. And that just, you can't hurry it. If you got to cook it for 8 minutes, you got to cook it for 8 minutes. So, yeah, so I think in the beginning is easier. And then if we have time at the end, and then the book is due the 20th, right?
Yeah.
And so this is, Thursday. So,
Next week, yeah.
oh, yeah, so then Tuesday, you're right. So it has to be before or after the lab. It's really hard during the lab because I need to watch everyone. I need to make sure that nobody gets set on fire or something like that. So I'm not really focused on what somebody talks to me about unless it's really short. And that doesn't give you the right attention.
I spilled E. coli on myself yesterday, so
Oh, yeah.
I get it.
Well, I gave you enough attention. I wrapped your foot in whatever.
Yeah, one
That's right, you
shower.
Yeah. Okay, so we do have a little lecture that we're gonna do. It's probably gonna be a little after 8. I don't think I'm gonna do the other one, but I'm gonna point out the important things that you need to know for the next part. Because these lectures now are things that you're also gonna see in the lab manual, where it tells you these are the organisms and these are the temperatures that they grow and stuff. So I at least wanna touch on it in the lecture. Yes?
I know I've had a lot of questions. Last one. I saw that we have that paper is going to be the next like larger assignment that's going to be due.
On the paper?
It's like early April. It said it was due.
Oh, it's for the
It was the
for the gram-positive?
yeah, gram-positive pathogen paper. How long do we have to do that?
And the paper's a lie.
Oh.
So that's left over from last semester where it is this big written thing, and I had all these instructions and stuff. So I told the coordinator, I said, so you have to give me more information. What do you mean paper? And he goes, well, there's one paragraph. I go, paragraph is not a paper.
Okay.
So here I'm telling the student you have to write this paper.
I thought it was a paper too.
Yeah, and he said, no, it's just a paragraph, and then the stuff that you do in lab. You'll look at that lab, and it will be like 8 or 9 pages where you write down, this was the color, this was this was that, and you're filling in blanks. You staple that together, you put it with this little paragraph and a couple things written, and that is what is turned in for, I think it's like 30 points.
Yeah, 25.
Yeah, something like that.
Okay.
So I kept saying, what paper do you have to write for 25 points? That's not enough points to write a paper. So they said, oh, no, it's not a paper, it's like a paragraph.
We're gonna have a paragraph describing what we did on.
Well, I don't remember exactly the thing now. It brings back memories when you said paper, and I'm going, paper? We don't have a paper, do we? It brings back memories with this thing that was so much just written stuff that you filled in with blanks, and then that was stapled to this other little sheet that was on the top. Yeah, I'll give you a lot more information about it before we get there. But that was another easy point one. That was another pretty easy point one. However, there were some people that totally got their organism wrong. They looked in the microscope and they went on the wrong path because that was it's a pathway thing. And they veered off over here. And so they got totally the wrong thing, and so most of the points were missed. But most people got the right pathway. Okay, so let's go ahead and delve into this. And this is, I do want to talk about this first lecture because I want to talk about some questions I would like to ask about it. And so I want you to think in a way that is more never having seen something before and having to put 2 and 2 together. So let's see, this is going to be the desktop PC.
Professor, for the
Yes?
lab report 10, there's 4 boxes, but we only did 2 organisms, so do we cross out the bottom 2 boxes on the lab report for number 10?
Yes, well you did your table only do 2?
Yeah.
Okay, yeah, last semester I think we did, each group did 2, so that you had 4 altogether for your table. But yes, whatever you did at your table, that's all you put.
Or was it the same?
Yes.
Well, I drew it, but
Multiple slides.
E. coli and, microcosm lucidum. I haven't written anything. Micrococcus lodius. I know, I haven't. Oh, no, oh, the actual.
Those slides. So that means you have to get an application.
Did you have to get your slide for the, you got one of them, didn't you?
It wasn't very good.
Was it like washed or something?
It was one, I keep watching.
Oh, yeah, that was, I'm trying to remember.
Yeah. Keep watching.
Because he got hired down or something, if you leave it too long.
Yeah. And I think that's what I think about it. At first I did, I mean.
So our projector is not on. Okay, oh. So let it shut all down and I'll just start again. John?
I don't know when. Then I left my house.
You picked up the green at 12. You're like 12 and 11.
Okay, so I'm a little at a loss. This is not turning on. Did you see it turn on at before? Yeah.
It was blue, but
It
got the
did,
projector
okay,
on.
so it was blue though. Okay, so it maybe I have to log in and then it'll turn on. We'll try that. This is on, so why?
I was looking at it. Microconference. Yeah, microconference. Bacillus. Harry Potter.
And the microconference.
Is there a little button I can push? Oh, not probably not.
Like on the top, you're gonna stand on my desk?
Well,
Sign me up.
so I'm not sure why this will not,
You turned on earlier.
it did, I thought. So I just logged in,
Oh, I spelled it wrong. It's Lubius.
I've got I've got something for it to look at. Here's a slide. You can look at it if you want. So now it's up to you. Okay. This is on, but it's a very faint one. Desktop. Projector. It keeps going off. Projector. I'll just hold it. You must turn it on. Oh, that did it. Okay, so projector status off. No, to be on. Projector status. Lamp hours. Somebody would leave it and not, maybe that's why it was so pale blue. Okay, so it's on. It says okay. So now I can return. It's on. Oh, it's waiting. It says please wait for it to warm up. Do you want to see this? Trying to warm up?
Is it usually like this?
No. I mean, usually when you start up and log in and stuff, it turns on, but when I forced the projector, I kept the button down for a long period of time. It finally flashed, and then it says it was off. So then I pushed the on button, and now it says, and now it doesn't say anything, but the projector's, the little thing is dark again. So I hold this down again, and okay, now it says it's on. Projector's on.
I think it takes a minute to warm up.
You think it just has to warm up? More warm up?
Maybe, I don't know.
How much warm up you have to do? Okay, so this says the status and it's blinking. So what does that actually say? Ooh, it says waiting. It says okay, waiting, okay, waiting, okay. Lamp hours. It says it's okay. Projector status is waiting.
Week 6 lab exercise.
Oops, sorry. Sorry.
I thought it was gonna talk to me. Do not use these controls to turn the system off. Press return and use the off button. Well, I'm not gonna turn it off, I don't wanna do that. I'll do return though. Well,
Do you want us to try and help you?
yeah, are you a good expert at that stuff?
Technically, technically,
Couldn't hurt.
extra credit.
Yes, that is right.
Maybe try the remote too.
Yes, it is 6.
Yeah, try the remote.
The remote sometimes would start.
Oh, is there a remote?
There
I
should
don't
be.
think there's,
Well,
no, that's my little clicker thing.
Did you have this plugged in last time?
No, I tried it because I was gonna use my computer, but I didn't. I usually don't use this. Yeah, it's just
You're
this.
signed in and, okay.
Uh-huh.
Alcohol.
Yeah, that's why I tried to, I forced this, I held that clicker down for a long time.
I know when
Oh, yeah, it hasn't been on. Yes, mine.
What up? How do we know here, what
See, this is what they call teamwork.
If you go to,
I was gonna use it
you go
because
to,
of
sorry,
my
you go to
laptop,
modules,
but,
right?
Yeah, go to module.
So this is where we did, last week, I think, or this week, the 10, 11. So if you click on it, it'll tell you in lab Tuesday, 10 and 13. So that's the pre-lab that she wanted us to do on Tuesday. And then on Thursday, we're gonna read the results and also do 12 and 11. So you gotta do the pre-labs for 12 and 11.
yeah,
Recording
yeah.
I'm so sorry. What up, Vince? That's for you. That's for
These are emergency steps you did.
Yeah, so just look on the modules and I'll tell you that.
Yeah, is that not what it is? Did you fill this?
Because it did have
I'm
some.
saying if you missed step 3, what color? Yeah.
Okay, so definitely only one section of the lecture.
You would never remove the blue everything should be. Because the iodine takes it out of the,
Right. It's going faster to warm up than it was to cool down.
Isn't it,
Oh, I hear it.
doesn't it only become purple after the
Look at it.
sterilization?
It's doing it.
After
Oh.
I tried that. It didn't work. That's why I.
Hold on, I'm gonna.
Yeah, I think you're absolutely right.
It's tricky, but
Yep.
Whenever you do it, I'm like, that's not on there.
Yeah, and then I thought we were all set until I was talking, I was come up and turn it on, and I did not do it.
For water.
Almost.
It gave me no effect, and then for
No, because they, wait, are these?
water runs out the decolonization, and goes back on.
No, I'm gonna double check it now.
No, that's fine, that's fine.
No, I'm not. Okay, good.
No, I usually don't do that, I just do this.
I was putting what this tells me.
So then they know this is what I want.
I'm not.
It should now show this. Yes, yes.
I know for next time.
Thank you.
We'll help you again if you need it.
it would not
All right.
effectively
All right, so
use the crystal violet.
let's go and talk about this. So you know, there's a question that you're gonna have in there about whether if you don't have one of the dies or you do it oddly, right? See one of the questions that were in the post-web?
Yeah.
Okay.
Too.
Yeah, so maybe this is a good thing that you can think about together. So you have different dice that you do, and you do them in a certain order. And so what are the dyes for? What's a crystal violet for? It's a primer, it's gonna stain everything. And then you have the mordant that you put on, the iodine, and it makes it bigger so it can't get out as easy. And then you put the alcohol, and that's gonna wipe off some of the membrane, and so the gram-negative is gonna be able to get away. And now it's still gonna be purple, but then the gram-negative has no color, right? And then you put the safranin, and the gram-positive still has a really dark color, so you just have a little pink in there, but you won't be able to see it. And now you'll be able to stain the gram-negative. So now let's say, what was the question that you had? It didn't have the, we switched the safranin? Was that the question it said? We didn't do one dye and then we did the other?
Are you saying what like the paper says?
Yeah.
Oh yeah, it says that, well, it says that the missing steps that we were supposed to do, but we missed, was crystal violet iodine and water rinse after grams iodine, then the decolorization agent, water rinse after decolorization, and then separating.
So we missed all those steps?
That's what it's saying. If we missed all these steps, what color would it be?
I think asking, like, what would it look like if you didn't do that step?
Yeah. Which step are they?
All those,
Didn't,
all steps that I
you didn't do any staining?
Yeah. No, like, I can show you.
And it's hard to explain.
Yeah, no, so it's saying that if we didn't do any of these steps, what color would it be? That's what it.
Okay, so it looks like a missing step is crystal violet on step 3.
Yeah, so like, if you missed that, then it would be.
If you didn't do that, then what color would the sample be?
What's the only color that we stained it?
It would be.
Saffron, it'd be pink, right? Yeah.
So they're just all pink down?
Yes, because pink stains anything. It doesn't matter what color. It won't. It's not differential. It's just another color that they put on.
So but it also says at the very end, we didn't do safranin.
Okay, well, this is only this step. So this one you would have an answer. And now you forget all that, and now you say, oh, but on step 5, we forgot, but you did everything else right.
So it's not saying
No.
all these together, it's just saying.
No, yeah. Yeah, so they're saying, pretend you did everything except you didn't do this one. And you get to the end and you go, hey, did you put the crystal violet on? The guy said, I think so. You know, he goes, why is everything pink?
Okay.
So then the next one you say the grams iodine. And you'll say, why did this escape so easily? So that's the idea. Okay. That makes sense? Yeah. So you can, once you know what they do, and then you can eliminate it, you can figure out what the end result's going to be. Okay. So those are the kind of questions I like. Because there's not a question that you can say, oh, you didn't teach us this. But if I took, you learned the whole series, and then you remove something from the series, you should be able to figure out what the end result is going to be. But that would not be something that you had learned or were taught, but you did learn what the sequence was, and you understood fully what each member of that sequence did. So removing one would allow you to determine what's going to happen to the end result. Okay, and so I do have a couple of those ideas in here. I don't have the iClicker things out, but I think that's just going to take some time to do it. But I'm going to fashion it as an iClicker. So let's just kind of start with this. This whole microbial nutrition and growth, the next lecture that was, I was going to dovetail onto this, is what happens when your bacteria grow too well and you want to start to kill them. So it's things like the autoclave and some of those other chemicals that we can use to heat and stuff to kill organisms. But let's just cover this one today. So microbial growth, it's just, we're not really thinking about one little guy getting bigger. We're thinking about a population growing more. And that brings us to the idea of a colony. We've seen our plates now. We have a colony on them. And so that little colony, it started 18 hours before you see it. So a little pinprick came up, and then it grew on top of each other more and more and more. And that's why we call it a colony-forming unit. It is not one bacteria, but it came from one original bacteria. So colonies are just an aggregate of these single cell. And when they say up here they hope, if you are trying to isolate an organism on a plate, you want to make sure you isolate something that's far away from other ones. So let's say you said, well, this purple one right here is really neat. I think I want to try to grow this one. You have a good chance of taking this one and the background and maybe this one with you. You think that they're far apart, but as far as microbes microbes are concerned, they're really very, very close. So even a needle probably is going to take more than just one organism. So that's why we spread them out, and then we take a clearly isolated colony, and then we move forward if we're trying to isolate a specific organism. In our biofilm, we kind of know what that is already. These microbes that are all going to be communicating together, we'll talk about how they communicate through quorum sensing. And then growth requirements, of course, it's going to take a lot of different nutrients to have all the organisms grow. And some of the ones that we really think about are carbon, oxygen, nitrogen, and hydrogen. So we want to know, where do they get the source of these things? And that's some of the things that we'll have on the slides and we'll talk about. So this slide is, well, this is the same slide, but it's a little bigger and brighter. So what we're looking for is two sources. We have energy up here, so we can have a light energy or chemical energy, and then down here we have the carbon source. So every organism needs to have an energy source, and then they all have to have a carbon source. So if they get their energy from light, like photosynthesis, then they are going to be considered a photo. So whichever they are, could be photo. If they use carbon, it's auto. So if they use carbon dioxide, they feed themselves off the carbon dioxide in the air. So light gives them the energy, and carbon dioxide in the air gives them the carbon source that they need. So those are photoautotropes. So that's this term. And then chemoautotropes, they're going to use a chemical for their energy source, and then they're going to use carbon dioxide for their food source. So this is their energy source, a chemical, and then carbon dioxide for a food source. And organic compounds are things like sugars, etc. Organic compounds usually means they have oxygen, carbon, and hydrogen in them. So CO2 just has carbon and oxygen, so it's considered inorganic. And then we have photoheterotropes. These are the ones that get their food from an organic molecule. It could be glucose or some other molecule like that. And an energy source, again, if this is going to be from chemicals, there would be a chemo. And hetero always means it's going to be a food source from another organism that produced the food. So glucose is generally one that's produced by another organism. So one organism can use that glucose, just like we use plants and animals, etc., to get our food source, our food source for our carbon. Okay, so that's really all this is. It's all on one slide. It's well put together, but this is something that you should just understand what the terms are. And in the textbook, there's a kind of a list and a definition for them. And now, oxygen requirements. This is very interesting for bacteria. We have bacteria that are what they call obligate aerobes. So they must live in oxygen or they will not be able to survive. And then we have obligate anaerobes. And so if it's an obligate anaerobe, oxygen itself will kill it. And you have to think of why. So why would I'm going to try not to talk too much, but the chapter is really pretty interesting. But why do you think that oxygen is deadly to something?
Because it reacts differently?
It does react, and what it does, it's oxygen is a oxidizer, so it's going to gain electrons, and when it does that, it's going to become a radical. So we all talk about that. It's we want to make sure that we don't have any oxygen radicals in our body, and we take some substances to try to get rid of those oxygen radicals. Bacteria have the same thing. So they have enzymes. So they have catalase, and if you start looking at your tests that you'll be doing for your unknowns, you will use catalase to kind of figure out what kind of oxygen source they may be using. And you'll use superoxide dismutase. And so organisms that consume oxygen and for their electron transfer chain, they have to figure out a way to detox these radical oxygen molecules that they consume. So they use those two enzymes. So if we want to know if something is a obligate anaerobe, an obligate aerobe, then we can also tell whether it's got these two enzymes. If you're an obligate anaerobe, you don't have those enzymes, and therefore the oxygen radicals will build up and will kill the organism. So this is the oxygen that is poisonous, and it's poisonous because it becomes a radical. These are very toxic. They're oxidizing agents. They can interact with proteins, lipid membranes, cell membranes, etc., and they can destroy them because they are radicals. So here we have our aerobes, and these are respire under aerobic conditions. So those are good. You know, they have enzymes that will allow them to deal with the oxygen radicals. Anaerobes, they don't, so therefore they will not survive in oxygen. And then we have facultative anaerobes. E. coli is a big one of these. And this is what I wanted to draw on the board, if I can get a marker. Facultative anaerobe is an organism that will grow with oxygen or without. So that's really a unique opportunity for an organism to take, I guess I won't write on the board. That's a really unique opportunity for an organism to be able to be in several different environments and survive.
Start getting.
Here's a question.
Yes.
Question.
Yes.
I just have a question about the slides. On the previous slide, there's parts labeled in bold, like they're, highlighted in black. Are those things that we should, take extra notes of and make sure that we know, or are they just on there just because?
They are kind of the highlights of the slide.
Okay,
Yeah,
so those are key points that we should know?
Yes.
Okay.
So I'll see if there's, and then this is a good slide. I kind of mentioned that, but you're right. These are key points of the slide.
So when I go back and I'm taking notes for studying, I should focus mostly on the parts that are bold?
Yeah, I mean, there's, if you only have these two words, you kind of have to figure out what's before it to figure out why those would be bolded.
Yeah, but the parts where it says forms of oxygen that are toxic are highly reactive and oxidizing agents.
Yes, and that's the radical. That's the oxygen radicals.
So that's that, for example, would be a point that I should make sure I know.
Yes.
Okay.
So, since you mentioned radicals, do you have to learn the 4 toxic forms?
Learn the what now?
4 toxic forms of oxygen that's in the book?
No, you don't, because I won't ask you actually to write each of them, and we won't see them on the slide anyplace else. But it's always interesting, so if you read it, and it'll stick in your mind a little bit, but I'm not going to ask you to detail them. Yes?
Can you explain the difference, for the slide afterwards, can you explain the difference between aerobic metabolism versus aerobic respiration?
So, from this slide, or?
From this slide.
And so your question again is aerobic respiration?
Aerobic metabolism versus aerobic respiration. What's the difference?
So respiration is when you are using an electron transport chain and you are taking in oxygen. Okay, so you're respiring. I think that's the only thing I can think of. You're respiring. And then this is the animals, they do not use this aerobic metabolism methodology because they can't take in oxygen.
They use chemical, right?
Yeah. Sometimes it's chemical, sometimes they do fermentation instead, but they just can't do the
Will fermentation require oxygen
for some cells, but we can also have fermentation where oxygen is not the electron,
Catalyst.
it's not the final electron acceptor. So these facultative anaerobes, and this is what I wanted to draw something on the board because I wanted to ask you this as a question later on, but I can't believe I don't have it. So what I was going to draw is I was going to draw a graph. And on the graph, on here would be the amount of cells, okay, the growth of the cells. So your cells are growing up like this, and over here is oxygen. So this means you're getting more and more and more and more and more oxygen, and this would mean your cells are getting growing more and more and more. So you would kind of imagine something that's aerobic. The more oxygen, the more growth. So it would go like this. That make sense? So then if you have something, let's say I show you a graph and you have almost a straight line on the bottom, meaning it's not growing any. The more oxygen you get, it doesn't grow. And then you have a line in the middle. So it kind of grows, but it doesn't. And then I asked you to take aerobic, anaerobic, and facultative anaerobe. So to understand that facultative anaerobe can grow either way. But if an organism has a choice to grow with the oxygen or without it, the only benefit is because if you grow with oxygen, you get the electron transport chain and you get all of that ATP. So you grow like crazy. But if you don't have the electron transport chain and you are able still to grow just by going through glycolysis, you get only a few ATP. So this line that is not at the bottom but not nearly at the top, this line would be what you would select for a facultative anaerobe without oxygen. If I said it had oxygen, you would say the facultative anaerobe is going to be just like an aerobic organism because it wants to grow as fast as possible and it's going to take in the oxygen. So this is E. coli. So E. coli, it could be on the bench top here or the desktop, and it's not, and it's going to be like facultative. It's going to be like aerobic here because it's in the air. But when you consume it, it says on a pencil or your fingers, and you put it in your mouth, and it gets down to your stomach, it's not going to grow very well. Okay, it's still going to grow in your stomach, but not as well because now it doesn't have oxygen. Okay, so it's going to slow it down. It is considered a facultative anaerobe. All right, and then we have aerotolerant ones. These are just additional names, and they have aerobic metabolism. They have some of the enzymes that can detoxify the oxygen, but not a lot. And these microaerophiles, they don't have any of the enzymes. So their ability to detox the radicals is limited. And so they only can grow a small amount at like 2% oxygen. And they take their risk. So they grow so much that even if some of them die off, some are going to survive at that low level of oxygen. And you would see this. Also if you have your textbook, the marker, I can't believe it. You would see it. You would have different tubes. And in the tubes, you would see a lot of growth at the top. So you'd have a tube like this, and you'd have a lot of growth at the top here. So what would you think it was if you had no growth down here in this media tube, but you had a whole bunch of growth at the top?
Fungus?
Fungus. Well, it likes oxygen, whatever it is, because it's right up here at the top. So which one of these would you say it is?
Aerobic.
Yeah, it's aerobic. So let's say you found another one, and the growth was all down here. There was no growth at the top. It was all down at the bottom.
Anaerobic.
Yeah, probably a strict anaerobic. It's going to kill itself if it gets near the top. And then you have one that's speckled all throughout.
Facultative.
Probably a facultative. And then you find one that maybe is, it's just a little bit below the top part. Maybe when they can't be in full oxygen, but maybe they're just a little bit below. They can have a little bit of oxygen. So you might say that that's a microaerophile. And then this is tolerant. It doesn't really care, but it doesn't need to have oxygen to grow. So that one also would grow throughout, but not nearly as robust as something like a facultative. So there's a figure in your textbook that has all of these listed. So you will see something like that, and you will have to make choices based on information I give you. Okay? So just so you can recognize that, and it is in the textbook. In most textbooks, they have these oxygen requirements for organisms. Okay, and this is just really to reiterate a couple things we talked about. Organisms need carbon at least, and so we know where we get our carbon from. We get it from other organisms. We eat plants, etc., and they all have carbon in their system, and so that we break that down and we get our carbon source. But nitrogen is something that we need. Our air that we have is 78%, I think, nitrogen gas, N2. Oxygen is only like 28% of the air that we breathe. So nitrogen is huge, but we can't break it down. And we need an individual nitrogen molecule for DNA, for proteins, for lots of things. And the only way we can get it is for us to be able to get it in a form that we can use it, which is usually like NH3 or something, some other kind of molecule. We can't use nitrogen gas. So anyway, this is, it's kind of a limiting factor. We need to use these to build up our proteins and our nucleotides, but we can get it from our diet, and we can get it from breaking down other materials. Okay, so these are one things, and this is where the environment gets bacteria can take in the nitrogen gas, and they can break it down. They can feed it to plants. We can eat plants. We can get the nitrogen from the plants. Okay, and then these are some other things that we really need. Obviously, we need phosphates for our phospholipids, DNA, RNA, all those molecules. This would be something that I would ask you because in theory, you know what some of those molecules look like. So you know that phosphorus would be in the phospholipids. They would be in DNA. You know it's part of the backbone. ATP. So you know phosphates would be in there. And same thing with sulfur. I don't ask you to know any of the R groups of the amino acids. But in this particular slide, it's telling you that you actually have an amino acid with sulfur in it. And a really important experiment was done when they determined viruses and how they infect bacteria. And they did it by differentiating phosphorus and sulfur. And they used lipids and amino acids. Okay, other things that we need in very trace amounts, usually you can find them in lots of drinking water and lots of foods even have trace amounts of minerals that we need. And all of these are things that you just have to have a healthy body. And the growth factors that they talk about, these vitamins, amino acids, other things, this is NADH, and this is a vitamin. And that particular vitamin is really important when we looked at the electron transport chain. Remember, NAD plus was a molecule that took the electrons and the protons when we were stripping them off from glucose as they were being consumed in the glycolysis. It went to this molecule, NAD plus turned into NADH and carried the electrons and protons. It went to the electron transport chain. Those electrons and protons were stripped from the NADH, and it made ATP. Okay, it went down the electron transport chain and made some ATP. Okay. Question, or you just?
Yeah, I think I have a question. Do you ever have for the other chapter, you kind of reposted somebody else's explanations, like a lecture?
This is it. Yeah, this is posted for. They'll have her verbiage on it. Yeah. I didn't want to do too much of that because someone said, "Can we speed her language up?" I mean, you get after a while. Thank goodness that it is the tech that we have on Thursday that comes in from I think 6 to maybe 9 or something, or 8 or whatever it is. That's his mother. So thank goodness nobody said anything in front of him. Because we had just gotten done listening to these and saying, oh my gosh, when you have to listen to the lecture. And then he goes, oh yeah, that's my mom. And then of course when you're listening in the classroom, he can hear her voice, because she's the one that also does all the things on Gramstain and whatever. So, yeah.
That's so funny.
Yeah, you know, she
that makes a lot of sense.
Anyway, so NADH is really an important molecule. Heme is also carries the oxygen in the blood. So these are some of the things that you need in order for, bacteria need to be healthy. We also need that. This is just to show you how your proteins are. So this is the growth rate and this is temperature. And so this is what happens to bacteria. At a certain point in time, this is their optimum growth. And then all of a sudden they start to crash. And normally they start to crash because the temperature gets too hot. And then it means that their membranes start falling apart, their enzymes start denaturing, and it kills the organism. So that's how heat kills bacterial organisms. Okay, and so this, I'm glad we could get to this lecture because this is what we're going to see. We won't be plaguing them like this, but you're actually going to have to take the OD readings of all of the temperatures. So that's our OD project. You'll take those cultures that you had and we'll see what their growth rate was. Now the bad thing about it is the growth rate has been for a couple days, right? So it's probably going to be really, really high. And so the OD rating is going to be 1.2 2 or something, that's off the chart for us. 1 is maximum, and now we're gonna be off the chart. So I'm not sure, I'm gonna give you some other numbers, I think, to work with, but we'll still have to do the OD readings. Okay, so if it's too high, the membrane's gonna fall apart, and cell organelles are not gonna be very stable. So high heat is not good. And here is one from, I believe it's in our lab manual now. You see this exact one. This is cold, cycro. Infile means love, so this is cold loving. This is kind of the middle of the road. This is what our temperature is, so we're right here, so that's mesophiles. And then these are just getting warmer, and then these are getting really hot. We're not concerned about getting infected with any kind of organism that goes through here because our body temperature isn't high enough to sustain that. We can get, there's another one in here that's not on here, and it goes from 0 to, I think it's 35, almost right in the middle here. Maybe it's up to 40. So these are, this is a cycrophile, and this, the other one is a cycrotrope. And a cycrotrope is the one that can grow in your refrigerator. It's the one that has listeria. So the outbreak that they always have in ice cream. So you go to put it in your refrigerator to keep it cold enough, and it's just growing like crazy because it likes to grow at that temperature. Yes?
What temperature does it plateau at?
I don't know exactly the plateau, but it's from here to here, I believe. And if you look at the slides that, I don't remember what her name is, but anyway, the ones that have these slides, she drew in. She went from here over, and I don't know if it was higher than this, but then over to about right here, showing that there was this big region that that the organism, Listeria, actually grew in the same temperature that our body grows, and that's how we can get infected. But it also can withstand really cold temperatures. So you think, oh, you're storing your ice cream in something safe, and the Listeria would die, but it doesn't. It likes that temperature.
You said cyclotrope?
Yes, trope, T-R-O-U-P. Okay, and the cycro just means cold. Okay, so we have this this chart in our lab manual. So that's why I was glad we kind of caught up, because many of the things now, the lectures, are stuff that you need to have for the lab manual. The lab manual explains it, but not a lot. Okay, so pH requirements is also some organisms, neutrophiles, that's kind of normal pH, 6.5 to 7.5. And then acidophiles, this phile again means loving, so this would be acid loving, and this would be alkali or base loving. And so there are certain organisms that only grow at those kind of pHs. Obviously, it's not really helpful to us. Although lactobacillus, this is an organism we don't work with, but if you eat yogurts, you probably read it in a lot of the labels. And in maybe probiotics and stuff, you read it in a lot of labels. If ever you are, if you get in a situation where you have to take antibiotics, and so you take them and they're targeting a specific bacteria in your body, it could also target some of your own microbiota. And for women, this sometimes happens where it attacks a lactobacillus or something in the vaginal area where it produces an acidic environment. And if that bacteria is killed off, then yeast that also would like to grow in that area, they take over. So women get yeast infections. So the first thing a doctor does is not only give you some kind of medication, but they're also going to start hoping that you'll replace your own microbiota that was killed off by the antibiotics with lactobacillus. So it's one of the most common ones that will help replace that bacteria back into the vaginal area, and then the infections will go away. So bacteria have, acidic bacteria have a good use for us. All right, and then for water, when you think about water requirements, for the organisms that we grow in lab, they're in water all the time. So they're in a media, and this kind of goes with what a buffer does. So the media that these organisms are in, they will secrete waste products, and they will also ferment. So they will eat, and they will ferment, making acids, and then they will eat, and then they will give off waste products where they're basic. So that means their media is going to get higher pH or lower pH, and it may not be the optimum pH for those organisms to live. So we have to put a buffer in. And what a buffer does is it keeps everything in homeostasis. It keeps it as near the temperature that you want. I'm sorry, the pH that you want. And buffers are designed to buffer at certain pHs. Buffer at pH 7, buffer at pH 9, buffer at pH 3, whatever it is that the body needs, it will produce a buffer using amino acids and their side chains in order to keep the pH in that region at the temperature that the enzymes that operate in that region work. Because you have to think in your stomach, you have a lot of really low pH, so enzymes have got to work at a very low pH. And that means they're going to have to be kind of buffered and keep it at that low pH. So you'll have a buffer that's going to keep that region around that same pH. Or you'll have other ones that you have to keep it at 7. So enzymes are something we always worry about. Water requirements as far as knowing what grows in water. We know that bacteria have to have moisture to be able to move around in and to survive in. Most of the metabolic reactions, not only for us, but also for bacteria, we already know. We looked at amino acids and we looked at sugars. They are hydrolyzed with water, and they also give off water. They're dehydrated, give off water, and then they're hydrolyzed with adding water back to them to make their structures going through the addition project. So also endospores and cysts, they also can live. Now this is in a dry environment. Most of our bacteria have to live in a moist environment. They would die without water, but we have some that will live in a very dry environment. And I think I mentioned this almost our very first lecture that we talked about, that there's anthrax, and probably everybody heard about the anthrax that they had sent through the mail. They had little spores from the anthrax. It got on some people, got into their lungs. I think several people did die. Other people just got disease. These are from endospores. And so this has been the big concern that many countries have, that you can take these endospores that are almost indestructible, and you can put them in a warhead, let's say, and you can shoot it over whatever region you want, and you can explode it. So they're immune to heat, dry conditions, water, it doesn't matter. And they will land wherever they land. The wind will take them someplace, and it'll be a vegetative area for there, and then they'll grow. So if it's anthrax, now you have anthrax spread wherever maybe you don't want it to be. So this has been something they've been concerned with for a long time, and it's because the endospores are so able to grow in almost any environment. All right, so these are things, osmotic pressure. I don't know if we've talked about that before, but there's two terms you really should think about. It's hypotonic and hypertonic. So these hypo and hyper are talking about the area outside of the bacteria. So the bacteria itself is going to have particles in it, it's going to have sugars in it, it's going to have amino acids in it, it's going to have particles inside of the cell. And all of those individual molecules are going to count as a particle. And outside the cell, it's going to either have more particles or less particles. If it has more particles outside the cell, it's hypertonic, meaning there's lots of particles outside the cell and very few particles inside the cell. And what will happen is the water inside the cell will try to go to the point of more solute molecules. And so it will try to go outside the cell. So if it's inside the cell, the water will go outside the cell trying to neutralize this hypertonic environment. So the cell will shrink. Yeah, we do this to our plants all the time. You know, the plant loses its water and it shrinks down and leans over and you go, oh my gosh, you water it, and the next day it's all standing up and perky and happy. So the same thing happens. So hypotonic means the water outside the cell has less particles. So that means the water is going to go from the inside outside. So one of them is going to go rushing in. So if it's hypertonic, reverse, water's gonna go out, and in hypotonic, the water's gonna go in.
So these terms always, hypotonic and hypertonic, always are in regards to the
Environment.
solution than what the
Yes.
actual water.
Yes. The outside. And this just represents how many particles they have in. A lot more particles, hardly any particles compared to the cell itself. And so the cell itself is either going to release more water to try to even out the larger particles outside, and so it will shrink up. And then hypotonic, the water will be rushing in. Okay, and here we're just talking about a couple more terms. Obligate always means must be. Halophiles. So this obligate, they need to have that 30% salt. And then facultative halophiles, they can tolerate salt. So they can have high salt or low salt concentrations, and they can tolerate it. Make sense? And this is just halophiles, they're salt lovers, and salt has different colors to it. So sometimes you can drive along the side of the road and you can see these crusty layers of something, and that might be salts that are drying up, and they have a specific color to them. Hydrostatic pressure, probably if you scuba dive or if you do things like that, you know there's water pressure, or there's the atmosphere is pressing down on the water, and as you go further from the surface, that means that the atmosphere is getting higher and higher. So if we go up in the atmosphere, it gets less pressure, you feel, and then if you go lower, like in the lower than sea level, then it becomes more, yes.
And then all of the organisms that we're basically talking about that go into the categories of barophiles or like hyperthermophiles and things like that, those are not classified as archaea, or are archaea part of those just on the
They'll be part of it, yes, they'll be part of it, because they're extremes, yes. Because most of the things that we even talk besides mesophiles could be archaea. Yeah. Yeah, and this is, you're right, being like 10 meters depth of the water and stuff and having all that pressure on there aren't any organisms that can live in our body that do that. We just, they would fall apart because they have enzymes and everything to keep them underneath that pressure. And you remove that pressure, they'll probably just explode. And then this is just biofilms. This is kind of what a biofilm would look like. It's on all kinds of things, and we've kind of just basically talked about biofilms. But biofilms are an organism. We consider it an organism because it is many different organisms, but it is in a kind of a sugary mat, and that sugary mat keeps anything from getting in. So it protects the bacteria, so it concentrates the things that are inside that mat that these bacteria make, and so it makes the food source close by. It makes, if they secrete something outside, they can pass that on to another member really quickly. They can signal to each other. That's what's called quorum sensing. So if they are in a biofilm, they can notify each other that, boy, our density is getting pretty high. We need to bust out. We need to have some of our members leave because it's too crowded in here. And some members will be escorted out. So they talk to each other through this thing called quorum sensing. And this is another question I would, if we had a lot of time to talk about this topic, a question I would ask is, so knowing about quorum sensing, knowing that bacteria in a biofilm, no marker, in a biofilm can talk to each other, and it sends signals back and forth, and when the signal comes back extremely fast, you know that the neighborhood is getting big. If it takes a long time for the signal to come back to you, you know there's very few of you. So if you're going to use an attack response, you don't want to attack when there's very few of you. You need to have a lot of numbers of bacteria to secrete whatever you're going to secrete to attack the host, so the host can't fight back. So this quorum sensing, if you know that, then one of the things you can do to alleviate biofilms, and if you're thinking like a scientist, you're thinking, well, if they signal to each other, let's mimic that signal. Because one of the things that are bad about biofilms is you don't know you have them until they start breaking out, and then the bacteria goes into your bloodstream. So if you could force that to happen when there really isn't a lot of bacteria, there's only a few, let's say you could mimic that signal and you could give it to the patient, and then that patient goes through the bloodstream and gets to the biofilm, and they think that there's a whole bunch of bacteria, so they have a response. And that might be to secrete something or to come out of the biofilm. And if that happens, then you can get the bacteria. But once it's inside the biofilm, antibiotics can't get to it, other enzymes and stuff can't get to it. It's really hard. It's covered in this sticky film. So that's one of the things they've thought. And so this would be a question that, if you were really forward thinkers, what could, knowing more about quorum sensing, how could that help you alleviate bacteria? Okay. Another thing you could think of is make a sister molecule, like a molecule that will block the receptor for the quorum sensing molecule. So other bacteria that are waiting for the signal, all of a sudden they get something and it's not the right signal. So they just sit there and they wait again. It's not time for us to do something because we have to get the signal. So if you could block the receptor that accepts those signals, you could stop the signaling for the quorum sensing. And that might stop the bacteria from being able to initiate some kind of problem. Okay, so those are the kind of things we could have talked about, but we don't really have much time. And these are just, if you're antagonistic in a biofilm and stuff, you're not playing nice with your members. And this is that you're symbiotic with them, so everything is okay. And this is synergistic, so you're just kind of offsetting good and bad together. Okay. Here is a little bit on quorum sensing. So you can see over here, there's not very many bacteria. It's sending out a signal to say, I wonder if there's a lot of neighbors over here. Should we now start something? And so the signal comes over. So, that's where you can think of what could you do now that you know a lot about quorum sensing to be able to cure disease, especially a disease that's caused by bacteria that are in a biofilm. Because they're really hard to get rid of. So this is culturing, and there's not too many more slides here. This is culturing microorganisms. We don't do that in this class. What we don't do is we don't take your plate and we don't look at your plate like this and then you analyze exactly what the colonies look like using a chart like this. So you could kind of pick at the colonies, you can see if they're kind of pasty, or you can look at the microscope, you can just take the top off the plate, put this underneath the microscope, and then look at what this little margin is right here. It's hard for us to see, but it could be all wiggly, or it could be filamentous or something. So we don't really do that here, but most microbiology classes will do that. They'll take an organism and it'll be part of the unknown, so that you can actually know exactly what your unknown looks like. Anyway, this would be a table that you would use, but we don't do this. So there's nothing on this table that I would ask you to memorize. Okay, just that if you needed to, there's a way, there's tables that you could look at a colony and determining more information about it. Okay, and then getting a pure culture, we know what this is. We know it's a street plate. So to get a pure culture, you want to make sure that you take a single organism. That's why we want at the end of this to have single organisms. We take a single organism, and then we will be able to do all kinds of tests on it. But this way, to get it to be a reasonable amount on a plate, we did some dilutions, and I think we all understand what the dilutions are. This particular one is a pour plate. So we took the bacteria and we diluted it down, and then we poured this into the bottom of the Petri dish, and we put some agar over it. So that's what they call a pour plate. And what this does is allows us to look at colonies not only on the surface, but underneath also. So this is the only way we can get anaerobic bacteria. Everything else we grow on top of the agar. And so that all we can ever look at is aerobic, or organisms that will live in air. But this gives us an ability to look at an anaerobic organism. Okay, by having, you pour the agar way down, or you pour the sample in the bottom, then you pour the agar on top, so the sample has the ability to stay underneath the agar if it wants to, so it's not going to be exposed to air. Okay. And yes?
Would you consider one, like either pour plates or street plates more effective to get like similar colonies, or like they're both the same?
It seems like I would, and so for this, you're only gonna get single colonies of whatever you put on here. But, if you're looking at a street plate, though, that you could actually, not street, but a spread plate, that way you could pour the same thing on top of agar and then vacuum it around like we did, and then you would have all on top a whole bunch of colonies, and they would be all aerobic. That's the problem. But if you're looking for a diversity, maybe you're looking for anaerobic also, then the only way you can do that is have a pour plate where your bacteria will begin on the bottom and then will only come to the top in order to get oxygen, and the rest who want to stay underneath and be anaerobic will remain there. So then you will be able to count in a certain area how many anaerobic ones you have and then how many aerobic ones you have. So one was only going to give you one kind of bacteria. Yeah. And the street plate doesn't really give you new bacteria. It just takes a single colony that you might get from somebody else, or maybe one that you're picking off, and you're just spreading it on the plate, trying to remain to get a single colony. Okay, and these are all colony forming units. We know what that is. Okay. And culture media, we have not used these. These are little Durham tubes. So we know that if we go through fermentation, that an organism will be producing acids or be producing whatever they are when they're fermenting. And what will happen is gas will come up. So the media that they will be growing in, they'll be secreting gas, and the gas will, instead of bubbling away because they're secreting it way down in here, it will go into this little tube that's upside down in here. And so you will be able to analyze whether you have a gas produced by your organism. I don't remember doing it last semester when we were here. I don't remember ever having any little Durham tubes, so we may not do that experiment. These are different kinds of methodology that you can be looking for different bacteria. If you have defined media, you can use that, where you give your bacteria only sodium chloride, you give it only sucrose for its sugar, you give it only a couple of amino acids, and that's it. And then you selectively, and you know exactly what you have, and then you define the media, and then you try to find your organism, or an organism. So defined means you know exactly what's in it. You have complex, and this means you have something called peptones in it. And what they do is they take a strand of amino acids and they cut it up into individual amino acids. You don't know which amino acids, but you know amino acids. So this is something that's complex. You don't know exactly what's in it. So if your organism grows, you don't know exactly the food to give it so that it will continue to grow. You will always have to give it peptone and hope the peptone, when it's all chopped up, will have the same amino acids that your organism grew in before. So defined is when you know exactly what your organism needs and you keep only that amount in its nutrient food. And then complex means you don't really know. It's a rich media. You just want anything to grow in there. Selective, you can put things in like dyes and things, acidic or basic dyes, and it can kill other bacteria. So you fashion it for a dye that keeps your organism alive but will kill other ones. So it's selective for only the organism you want, or a small group of organisms that you want. And differential, this is you're going to differentiate between things just like we're doing with our gram stain. Some things will grow and some things will not. So you're differentiating between one thing growing maybe on an acidic plate, things that will go in 30% salt, and things that will not. And then anaerobic, we know what this is. I'll show you a jar in a second. Anaerobic is that you put it in an environment that does not have oxygen. Okay, and then you'll test whether it's going to grow or not. And transport media, this is just broth and stuff that if you pick up a sample from somewhere, you need to transport maybe to a hospital or something. So you have a certain media that you do, either a broth or an agar that you do that with. And this is kind of an example of what something differential is. I'll talk about this slant in a second because we will be doing this. But you can see on this one is beta hemolysis, so this is a red blood plate, and I think this is, I forget what bacteria these would be, but this is, you can see it's clear. If you had that plate in your hand, you'd be able to read the newspaper behind it. It's that clear through the agar. It means that the organism is releasing hemolysins that lyse the red blood cells. And then this one, you can see it's kind of a grayishy green. That is gamma hemolysis, I think. Beta, gamma, yes. And maybe it's, I won't say that. I think this is gamma, I'm sorry. So I think this is alpha. Alpha, where it's kind of greenish. And then this is gamma. What this means is this is only lysing the red blood cells partially. And why would it lyse red blood cells? Why would an organism spend all that time and have those enzymes secreted to break up some red blood cells? It must be looking for something, right? Some nutrient that it needs. And so it needs iron. So red blood cells have lots of iron in it. So they lyse the red blood cells and they gather that iron. And so that's what keeps them alive. Okay, so these slants like this, we did slants, I think you, yes?
Would we need to know the difference between like alpha, gamma, and beta?
No, no. Yeah, it's not on the slide, so you don't have to know that. You just need to know that it's a differential, and they can use red blood cells for that. And here is a slide, or a slant, and we saw slants when we inoculated our organism. And next time that we see this, it'll be one of the projects that we do. So if you inoculate along this, you know how we did a little squiggly line, and then you take the same thing and you stab to the butt. What are you getting? It's like 2-for-1 information. Yes?
You're going to tell the difference between aerobic or anaerobic?
Yes. So you're going to have an organism that you wonder, I wonder if this is really also anaerobic. And so by stabbing the butt, if it grows, you'll say, well, it could be an anaerobe also. Or maybe really a facultative anaerobe, because it would not be a strict anaerobe because it would never just grow in air. So if it grows in air and you stab the butt and it grows, you know it's a facultative. It can grow either place. So these are really very clever to do. And then also you can see it's going to ferment down there because it'll change a color down here. So it's really kind of interesting. So we do it, I think, for both of the projects that are coming up. Okay, so here's what we call an anaerobic jar. This one has a candle in it that is kind of old-fashioned. They have packets now that you put in there that absorb all the oxygen and then let your plates grow in what we call an anaerobic environment. And then here, other ways that we can preserve cultures. You can put them in a refrigerator, you can deep freeze them, there's lots of other things. We don't do any of these. Lyophilizing, this is just like freeze drying them to store them for years and years and years. Okay. And this term you do not need to know at all, hemostats, but all the rest of them make sense. Yes?
So with that picture of the anaerobic jar, would you consider that as a low oxygen?
It'd be zero oxygen. So eventually the candle's going to blow out because it's going to absorb all the oxygen. It will burn until there's no more oxygen. When that comes in, then that jar is anaerobic. There's no more oxygen left in it. An old-fashioned way to do it.
So would it be considered an anaerobic culture, or what would it be considered?
This is the way that you would grow things that are anaerobic and need to be in an anaerobic environment. And it's an inexpensive way to do it. That's how they used to do it years and years ago. Now they have these little packets that you put in, and it absorbs the oxygen almost right away. Because anaerobic organisms, especially strict anaerobic organisms, they will die if they're around oxygen. So you want to remove the oxygen as quick as possible. If you have to work on it in lab, what would you do? Probably, maybe you've seen setups in pictures or something. If you had to work with an anaerobic organism all the time, maybe that was the thing that you were studying, how would you work with it?
In the hood.
In the hood, and you would have these gloves. So the hood would always be down, and you only reach in with your gloves, and you do everything with your gloves, and that whole environment is always going to be without oxygen. So it's not a pleasant way to do things, but if you work with an anaerobic organism, you have to keep it in its environment that's going to survive it. Okay, and this is just a little, this chemostat. I said you really don't need to know this, but and sometimes you want to keep a culture going forever. And so the culture, as I said, will have waste product that goes off into the culture, and it will have both basic and acidic waste products. And so that will make the culture, even if you buffer it, eventually it overwhelms the buffer. So what they do in this is they drip in brand new culture, and then they take some of the old culture out. So they're keeping it kind of fresh all the time, and as they take some out, some of the bacteria will also be taken out. So the concentration of bacteria remain just about static all the time. And so this allows you to grow that very precious culture that you have for a long period of time.
So with the experiments we're doing with growing cultures, will those be like enrichment cultures on like agar plates and broth?
Enrichment would be like you put blood on it.
Okay.
Yes, some things that the organisms get extra value for. Yeah, so that's the only way we enrich something. Okay, now this is, again, I was going to do a little math thing with you, but so here is arithmetic method of bacteria multiplying, and this is logarithmic. So this is how bacteria multiply. So this would be the way the normal public thinks. Oh, we have one bacteria, and then now we have two. That guy multiplies, and then that one multiplies. We have three, and then one multiplies, and da 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 da. So in only 7 hours, you have 1, 2, 3, 4, 5, 6, 7. 2 hours, you have 7 bacteria. That's how the normal public thinks what happens with bacteria. But they're logarithmic. So you may start out 1, and then in 15 minutes you have 2, and in 15 more minutes 2 times 2 is 4, and on and on. By the time you get to here, you have, you double this. I think this is like 64, and this is 100 and something. So you can imagine this is only a couple hours. If you leave it overnight, our cultures have a billion zillion bacteria in them, because every 20 minutes or so they are duplicating. Now, different bacteria duplicate at different rates. Sometimes it takes an hour for a bacteria. Sometimes it takes, 35 minutes or 20 minutes. 20 minutes is usually the thing. I think E. coli, they use that as a standard, and E. coli multiplies every 20 minutes. So I would expect you to be able to kind of do the same calculation. You start out with 1, and then you have 2 in 15 minutes, and 4 in 30 minutes, and 1 hour. I guess I did that wrong. So 1, 2, 3, 4, so this should be an hour. So you start out with 1, and then at time 0, 1, and then 2, and then 3, and then, 4, and then 8. So that should be every 15 minutes for an entire hour. So you should be able to calculate that for a reasonable amount of time, not 10 hours or anything, but something that's reasonable. And let's see, this lag phase, you see how bacteria, when they're growing, here's the number of cells and they're getting bigger, and this is log phase, so this would be like 0. And if this was 10 to the 1 for log phase, what number would that be? Yeah, it'd be 10, exactly. And then it's 10 to the 2 would be 100, and 10 to the 3 would be 1,000. So that's what logarithm is. It's going up by 10-fold every single time. So when you're reading some of these, if you see a 10 to the 1 or something, you think, oh, that's just 10. And then 10 to the 2, you say, oh, that's just maybe 20 or something. So you need to realize that those are logarithmic numbers. So in lag phase, bacteria, when they're starting to multiply, they have to get the signal that they're going to multiply, and then they have to get all their ribosomes. They have to get all more new membrane, because they have to make another cell besides themselves. They have to make their DNA. They have to replicate. So there has a lot of stuff that's going on in log phase as this bacteria is deciding to divide. And then it comes, and this is log phase, so it's dividing extremely rapidly. And if you were taking antibiotics, which phase of this would be the best one to do?
Log?
Yeah, the log phase, because you're going to get the most bacteria. If you do it down here, you're only going to get a few bacteria with your antibiotic. But here, and also in here, is where all the enzymes are being expressed. Everything is happening in this, because they're dividing. If you're making new cell walls, if you have an enzyme or an antibiotic that is going to kill the bacteria by damaging the cell wall, you want the cell walls to be being made. Here, the cell wall is already made, so you're only killing a few. But here, you're going to be killing all the new ones that are starting. Then once we get up here, this is what they call stationary phase. So stationary phase is new ones are coming on, old ones are dying off. So you're at a point where they're pretty stable up there. They know their environment, they've expressed all the enzymes they need to survive, so they're pretty stable up here. But it only lasts so long. And then they get into this death decline phase. And so that usually will take over and the bacteria will come down to a very, very small number. However, science has decided in the last about 20 years that these are the most dangerous. Because what happens in these bacteria, they have survived all of this time. And now they've had to just, survive when there's hardly any nutrients. They have a ton of poop around. They have all kinds of acids around. It's a horrible environment, and yet they're still surviving. And now, somehow they get out and they get into some fresh media. They grow like crazy. Because they are so conditioned to all these other harsh environments, they get into something good, they are super performers. And that can cause problems. So a lot of research has been done to make sure when bacteria are killed, they're killed, all of them, that we don't leave any that are in cultures. Even in labs and stuff, you have little vials and stuff like that. Those bacteria in there could be 10 years old, and they still can be alive. It's really surprising how they can survive. Okay, so anyway, here's lag phase. That's making new enzymes and things in order to get ready for this exponential phase, and then stationary phase, pretty stable, and then the death decline phase. So this is best for antibiotics. This is where we make endospores and things like this. This is where the bacteria goes, uh-oh, it's not the best place to be anymore. So maybe if we can form spores, we better do it, because pretty soon we're going to be obliterated. So this is a phase where lots of things happen that are going to help the bacteria survive. And this is a counting chamber that we were going to do in lab, but we're not. And I'll just tell you real quick what happens. Oh, let me see. All right, this is good, that one. This is a slide. The one that we have has little, oh, no, it's back here. Oh, okay, well, we're almost done. So the one that we have in lab has little chambers through it like this, and so you pour the media in here, and it just kind of runs down the edge, like this. It runs down the edge, and then you put the cover slip on top, and this cover slip is etched like that. And so when you're looking down on it, the concentration of the bacteria that, the solution that's poured into here is very, very small. So that concentration is enough for you to be able to count them. And so here's a big enlarged picture of just one of the squares. So there's 15 right here, and then you can just say, okay, I have many other squares, and then you can get a good count on what's in the culture. However, what do you think the problem with this is? I mean, we don't even know if these bacteria are alive. They could be dead, right? So here we're worrying about a culture that could have all these bacteria in it, and maybe they're all dead. Because just because they float around in here and they sit here, that doesn't mean anything. So this is kind of a non-direct way of counting, and it's not always the best way of counting. The same thing when we take our OD readings, all those bacteria could be dead in there. We have no idea. I mean, it's just, they're dense, and so the light bounces off of them. That doesn't mean that they're alive. What is the only way probably you can tell if your bacteria are alive or not?
Grow them,
Yeah, grow them. You're going to have to take a plate and just smear them on the plate. And so that means they're alive. And so you do the dilutions like we talk about, and you dilute them, and then you spread them on the plate. And you go, oh, okay, in that tube that we have, so many per mil are alive, because you can see that they actually plate. Maybe more or less than you think. Okay. So these are, this is a direct way that you can count. You plate them on a plate, and you can see. This is like a little filter, so they force all this liquid through. All the bacteria go onto a filter. They turn the filter over onto an agar plate, and then they count the ones that are on the agar plate. So as long as you have something that grows on an agar plate, at the time that you're counting, you know they're alive at that point. So that's the only direct way. the only direct way is actually to, like you said, count them, plate them on something, or grow them in a block. And then here's just, we've been kind of practicing this. So this is just dilution. Too many to count here, too numerous to count, 65, 6, 0. And so if we look at this, this is a 1 to 10, right? Each of the dilutions 1 to 10, 1 to 100, 1 to 1,000. And does it seem like these dilutions turned out well? Because look here, we have 65, and 10% less than that is 6, and then 10% less than that is 0. So when your dilutions on 1 to 10 come out where there's only like 10-fold difference in between each count, you really have good, strong dilutions. Sometimes it's because we're not very good at it yet. We have like 1,000 one time, and then we have 17 the next time. So there's a couple orders of magnitude that we lost in there just because of pipetting skills or whatever. But anyway, this is the best way to tell exactly what you had in your original culture, because you get the colony forming units per mil. So whatever's in your original thing, if you have a whole big vial of it, you know how much you have for live bacteria. This one is a probability count. It's not a very good one, but it has a unique methodology. So this is a phenol red, and this is a dye. So the phenol red will turn red when it's basic and kind of yellow when it's acidic. So they can look at these, and things that are acidic mean they're going through fermentation. Okay, so Casturin, his problem with the wine was being acidic. Well, the organism was going through fermentation. So these organisms are viable. All the ones in here are doing something. The ones in here are doing something here. These are not. These are already past that. This is all basic. So they're already just now swimming around in a waste material. So these are the only ones that are actually metabolizing right now. So then they use this count. You do about 15 of these tubes, and you use this little table. Nothing you have to know. It's just that science does some crazy things to count the number of bacteria. So, I mean, a probability table, and then you got 5 tubes, and so anyway, nothing you have to know. But they have probability tables that will allow them to determine. Yes?
So the red indicates basic conditions, or is it?
Basic conditions. So phenol red turns kind of red at 7.2 to 8 or 9 or 10 or something, and then it's yellow color when it's 6.6 and below. So 6.6 and below would be acidic, and if it's acidic, that means they're going through fermentation. So they're metabolizing here.
They're alive.
Yeah, they're alive. Yeah, and these over here, they're already basic, so they're not good. Yeah, so I mean, it's a crazy thing. When I came across that, I said, I don't know. There's got to be better ways to count bacteria. Okay, so again, a direct measurement and most probability number. And the other things, these are just kind of what we do already. We're going through our spec to look at it. And this is our spec counter right here. So, and there's other things you can actually try the bacteria and then know how much bacteria weigh, and then tell by the mass of them about how many you have. I mean, just kind of like an archaic method. Now this is cool. They can do it by molecular methods, so they can actually go through sequencing and figure out how many of the cultures that you may have in that sequence that you pick out. But still, I can't see how they can get an actual count. Okay, so this, I think, is the last slide that we have. So I know I need to fix it all. It's over. All right, so we have another chapter in here. I will just pick out just a few slides from that chapter. I will post both of these in the voice of the woman. I don't know where she is. But I'll post both of them in that format so that you can listen to them at your leisure. Yes?
What would you like us to turn into at the beginning part?
Okay, so we're doing experiment 11 and 12. Okay, so we already did 9 and part of 13. And 13, you've done those already. So it's going to be 11 and 12. The lab report, I don't think anybody finished for the last stuff. You still have to look at your results. That would be the ones that we do in the incubator. Yeah, I think we turned everything else in.
But the grams, maybe post lab needs to be turned over, 10?
13.
It was 10 to 13, yeah.
10?
So post lab 10's due tomorrow.
10, isn't that where we cultured?
That's the one that I brought to you. It's the one that we were asking questions, and I brought it up here and I showed you.
That's the same.
Oh, okay, so you have that, all the information for that?
For 10.
Okay, because that was just Graham City.
Yeah.
Okay, yes, so that one would be doing, what number that, you said that was 10? Okay, yeah, 10 would be due.
13
No,
is,
we didn't have the
And
results.
then 11 and 12 pre-labs would be due.
Yes. 13,
Yes, yes.
no.
Yeah, because you finished 10, that's
I
Graham
didn't hear,
City.
what was any post lab?
11,
Got it?
Yeah.
Okay,
Yes.
so goodbye, everybody.
Right, thanks.
Remember, we're a team.
Hi, Vince.
No, I see you, you know, who was this, a discussion about,
I'm sorry, was
did you
that?
miss somebody?